Good morning, Namaskar. This is my identity as professional engineer. Some problem here. Okay. This is my identity as professional engineer. And this is my identity as chartered engineer. And this is my identity as fellow member of Institution of Engineers India. And this is what we are going to talk in general: management, contracts, and various other issues, COVID, etc. etc. Miscellaneous talk, nothing specific. And good morning again. This is Suraj Singh, and this is today. Today, what I say, it is January 16th and Saturday. I know you must be taking rest because Saturday and it's early morning of winter, early morning of cold winter in north part of Bharat, India. Usually January is very cold, February is also cold, January is full of fog and cold, and temperature at present is 9 degrees in around Delhi. It may be down further, no problem. It's life, we have to keep with this, we have to move with this. I talk to you early morning because I got up early morning, and there is no problem of sometimes signals are available, sometimes not available in busy times, so I prefer to talk early morning. Though you may be sleeping, no problem, later on you can watch this video if you are not available now. And sometimes I like to add some Hindi tongue also in this because I have got certain complaints from some of my colleagues, some of my friends, viewers, that it's not easy to understand English all the time. So I should also use some Hindi language in that, though it's not international level. Yes, I'll try to use somewhere Hindi also in this talk, though it will affect my foreign viewers, no problem. Let them also see Hindi as a language, and I can't speak some other language, unfortunately. I can't speak Tamil, I can't speak Andhra Pradesh, some parts of Arabic I can speak, I don't know. But I thought to keep this confined to English because it's professional language, particularly in all parts of world. Generally English is used, it's not simply we are using English here. Even then, I cannot disappoint those who get up early morning to see my face and my video, and if they request something, it should be regarded. That's the only reason I'm trying to say that. Okay, I'll sometime take initiative to speak, though I cannot use complete Hindi because of technical words and other words used in this. बहुत से बातें ऐसी होती हैं जो मैं नहीं कह सकता, तकनीकी शब्द हैं जो दूसरे शब्द हैं इस प्रोग्राम में, इस एनालिसिस में, इस प्रोफेशनल टॉक में, दूसरी टॉक में, इट लीव्स टू ये आपकी ज़िंदगी से भी लिंक रखती है, इसलिए हर बात को हिंदी में कहना तो संभव नहीं है और हर बात को अरबिक में कहना भी संभव नहीं है. इसलिए हो सकता है जितने भी वर्ड्स मैं यूज़ कर सकूँगा इंग्लिश में, हिंदी में या दूसरी लैंग्वेज में, आई विल लाइक टू डू दैट एज मच एज पॉसिबल, बट आई कैनॉट एश्योर यू दैट it may be convincing to you, it may not be convincing, it depends upon your interest and your choice. This talk is very general. Today I am saying this date of 16th January and title being Civil Field Engineering, General Designs, Construction, Organizations, Communication, Coordination, Project Quantity, Quality. Why should one be behind quality of control, concrete standard materials and concrete standard work. Contact, this is 237 talk in series of this professional talk other than COVID and other than national issues. This is 237th in sequence. No number doesn't matter anyway. I think I didn't change number, is 238, no problem. It is 238 by mistake. I put 2000, let it be 237, no problem. It all doesn't make a difference. Yet it is civil field engineering talk, and civil means you know what is civil engineering and you know what are designs. Designs means we have to design. Everybody knows what is design. सबको मालूम है डिज़ाइन क्या होता है, और सबको मालूम है फील्ड इंजीनियरिंग क्या होती है. जो भी हम फील्ड में काम करते हैं, मकान बनाते हैं, सड़क बनाते हैं, रेल की पटरी बिछाते हैं, या कुछ और भी काम करते हैं, डैम बनाते हैं, नदी बनाते हैं, वी कंस्ट्रक्ट नॉट नदी, कैनाल नहर. We design and construct canals, we design and construct houses, we design and construct roads, and we design and construct whatever else facility for people of this country or other countries, airport, and you can say commercial buildings and whatever, bridges, flyovers, culverts, all sewer line, water line, whatever you can say, which are used for general public and civil capacity, that's called civil engineering. Is complete design and solutions, and its execution solution. It's that way we call, it's a professional's duty to involve with in all the specialties whatever are possible in life. Civil engineering is very bunch of many subjects, 35 subjects, 40 subjects one has to study in civil engineering, and which includes theory as well as practical. दिस वेरी मच हर इस इंजीनियरिंग को पास करने के लिए 30-35-40 सब्जेक्ट पढ़ने पड़ते हैं, और ये सब्जेक्ट ऐसे होते हैं इमेजिनरी होते हैं लेकिन प्रैक्टिकल देने के लिए होते हैं. दीज ऑल सब्जेक्ट्स आर वेरी मच थियोरेटिकल, कॉन्टेक्स्ट कैलकुलेटिव, फुल ऑफ कैलकुलेशंस, इमेजिनरी एंड हाइपोथेटिकल, बट ऑल दिस लीड टू प्रैक्टिकल वर्क. सो मच हाइपोथेटिकेशन इज देयर, यू कैनॉट इवन, मीन आपको कल्पना में भी नहीं हो सकता कि कितनी इसमें कल्पना है. वी इमेजिन बीम्स, हम कल्पना करते हैं बीम्स, वी इमेजिन कॉलम्स, वी इमेजिन स्लैब, वी इमेजिन बिल्डिंग, वी देन वर्क आउट हाउ टू मेक दिस इमेजिनेशन ट्रू, ड्रीम कम ट्रू. That is what engineering is all about. Means we imagine, oh, I'm sitting here and there is a beam I'm going to build. How long this should be, the span of the beam. Beam कितनी लंबी होनी चाहिए, ज़्यादा से ज़्यादा कर सकता हूँ इस मकान की, कितना ऊंचा कॉलम कर सकता हूँ, कितना कम साइज का या बड़ा साइज का कॉलम कर सकता हूँ, व्हाट साइज ऑफ कॉलम आई कैन गिव, व्हाट साइज ऑफ डायमेंशन ऑफ लेंथ of this height of this column and length of span of this beam, and what way I can do this building best way, how deep it can go into soil. All this is imagination depending upon various parameters though, but ultimately this all combinations of thought, contemplations lead to production of some structure. This is structure. Everywhere there is a structure. Whatever parts of civil engineering you take into your hand, you will find ultimate structure is destination, structure is parts of milestones, and without the structure may be imaginative, it may be on drawing boards, it may be on designs, or it may be on site execution, wherever it is, or it may be prefabricated or pre-stressed concrete or cast sensitive concrete or brickwork or block work or stone masonry. Whatever it be, it is structure. A simple wall is a structure, a simple footing is a structure, RCC footing is a structure, or you can say columns are structures and pre-stressed concrete is a structure. Everything is a structure in terms of that. Sometimes a small wall is a structure, you can say how it can be structured, you may ask the question, but that is a structure, that is a fact. So we should understand this point, that we lead a life of something imaginary world. Education be based on imaginations, and imaginations linked to reality. This means dreams, artificial dreams, you can say. Imagination is sitting and think of that, I'm going to start a building, first I have to think what I have to do. That's very important part. वो सबसे इम्पोर्टेंट कि मैं क्या करना चाहता हूँ, मैं क्या करना बनाना चाहता हूँ एक इंजीनियर की हैसियत से, या एक इंजीनियर में नहीं भी हूँ तब भी मैं क्या कल्पना करता हूँ. What imagination I generate and how can I achieve that, what is the method of that, how to process it, all these are required in engineering. Engineering is something which is, you can say, pure, having all kinds of activities within this sphere. It is a domain. It's not simply one activity. There are thousands and thousands of activities are involved in civil engineering. Civil engineering, some engineering which you can be proud of, that I'm going to do something from soil to gold. You know, you are doing something, you are going to create from soil particles to complete structure which is going to be used for many decades and many centuries possibly. You can say railway track, though it's not job of, but laying of track and fixing whatever to create foundation for laying of this track. Or you can say work of sewer line, work of water line, also work of road structure, work of airports, and work of commercial buildings, and work of, you can say, housing, and you can say work of atomic reactors, and you can say whatever temporary or permanent works, wherever you find cities and towns and village buildings, and you can say canals and water resources, you can say canals and dams, and you can say turbine foundations and machine foundations. So whatever you will go to factory sheds and factory buildings and whatever, you can say directly or indirectly, all do involve field of civil engineering. So it is the widest definition in your world because it's related to human requirements. It fulfills requirements of human all over world. ये एक ऐसी विद्या है जो पूरी दुनिया के अंदर, विश्व के अंदर सबकी मनोकामनाएं पूरी करती है. उसको कहते हैं सिविल इंजीनियरिंग, वास्तु विद्या ज्ञान. इंजीनियरिंग की हैसियत से आर्किटेक्चर भी होता है, लेकिन वो अलग है. आर्किटेक्ट आल्सो लिंक्स विद इंजीनियरिंग इन वन वे और अदर, बट अल्टीमेटली इट इज प्रोडक्शन ऑफ इंजीनियरिंग. इट इज इंजीनियरिंग प्रोडक्शन दैट इज कॉल्ड engineering. Civil engineering is the mother of all engineering, we can say. because civil engineering is basics of engineering. Without civil engineering, you have to start from scratch, from soil. Sometimes you have to clean garbage also before that. It's called site clearing. And you can say, means you have to deal with soil and also night soil. Both you are going to deal with. You are doing permanent soil, which is in your earth surface, as well as you deal with night soil or night excreta, which is, you can say, you pass out in WC, and this becomes ultimately, after getting decomposed into a state of grey color, and that's called sludge. जब आपको ये जो मिट्टी से, इसको मिट्टी भी कहते हैं, और हम खाने के बाद जो पेट में मिट्टी जमा होती है, जिसको हम WC में निकालते हैं, जिसको हम स्टूल कहते हैं, वो भी इससे डील करती है. We deal how to treat that soil, night soil, and how to take out sludge and take out effluent parts separately from that, from septic tank or from sewer line or from containment, whatever it is. That is what is civil engineering. I am not here to define civil engineering. I am just trying to explain to you where does it involve, how it works. Soil is basics of engineering all over the world, in all branches of engineering. Mechanical engineering requires soil because it comes out of soil, steel comes from soil, aluminum comes from soil, or you can say whatever minerals come from soil or from parts of others called crust, top part of others 35 kilometers from surface of what sea level, sir. Sea level down to 35 kilometers called crust, a structure of earth or lithosphere. Lithosphere means solid part of earth having water body also, and also air part. If you mix into that, becomes earth. Earth is called the lithosphere plus aerospace. Lithosphere is solid part of this plus water body. This is called seas and oceans. That's what we are doing. As a part of civil engineering, is a subject of geology. We call applied geology. Applied geology is a part of civil engineering. Without learning applied geology, one cannot become civil engineers in true sense, because applied geology gives a sense of what is earth. That's very important part. Lithosphere plus aerospace is called earth. Earth is very important part from civil engineering design and working views, because without learning, without this, you cannot move further. It's not possible. You have to understand what is geology. You have to understand the application of geology, because geology is a part which gives you a structure, a body of lithosphere or earth. Without learning, without knowing, which you cannot become civil engineer, perfect civil engineer. You cannot lead to a life of civil engineer. You cannot depend upon others to know. If you want to learn something, you have to do yourself. Doesn't matter if it's a part of your course or not your course. It doesn't give difference. You can read yourself. There's no much mathematics in that. It's a simple theory. You have to read that text and can become civil engineer, geologist also, because you have to work on with geologists, or you have to work as geologist yourself in your life. आपको geologist खुद बनना पड़ेगा, geologist का काम करना पड़ेगा आपको जानने के लिए मिट्टी क्या है, जमीन क्या है, कैसे भूचाल आते हैं, कैसे सब होता है, पानी क्या है, जमीन में कैसे एरोशन होती है, मिट्टी कैसे बह के आती है, ये सब जानने के लिए आपको जियोलॉजी पढ़नी पड़ेगी. इट्स वेरी इंपॉर्टेंट पार्ट. हाउ what is dust, what is sand, what is aggregate, and you can say what is erosion, what is soil particle, how it comes from mountains, it flows down to plain areas, and how river works, and how canals are constructed. Means those are not parts of life. We have to understand geology to construct whatever structure you construct, in foundations to construct all over the world. You have to understand geology of that area, and geology is not limited to top part of us, limited to whole earth lithospheric volume or structure, which is divided into three parts. One is called crust, other one is mantle, and third one is core. Core is the most middle part of Earth's diameter is 12,500 kilometer. Average you can take it 30,000 just for understanding. It doesn't matter. The top 35 kilometer parts called crust, and then they go to 3,000 kilometer down, you'll find mantle area, and further down to center of Earth you can say it's called core. So core plus mantle plus crust make lithosphere, and core plus mantle plus crust plus aerospace, which is about 20 kilometers about sea level, that's all is called earth. So we have to understand what is earth. It's very important, everybody understands it, but it's better to refresh all time, and this is purpose of this talk. I try to refresh all this. It's not that I'm telling you original work. You have studied by chance. People forget, because it doesn't come, that education, the value, the knowledge doesn't come to use in your profession all day, all times. So it's better to refresh that. So I'm trying to refresh that. That's very important part of profession. Refreshing, or you can say what you learned, you forgot, you remind that, called continuous education. Also, you keep up once you learn in beginning, and then you repeat it, and then you repeat it and revise it, then you get much better idea on that. Then you try to think on that, why study, what meaning of that. and that's meaning interpretation is different one for each subject, for each chapter, for each article, or for each theory. Once you do theory, you can understand what's that. So civil engineering, very different parts of it, and it's altogether different. It includes so many topics, as I explained to you. It includes something like that. I know when I talk of this. When I talk of project engineering, management, and total quality engineering, this is something different, when I talk of this. When I talk of this, it's something altogether different: project engineering, management, and total quality engineering. And when I talk of FIDIC, it's something contract. This 2017 red plus silver book is something else, which is further part of construction engineering, or you can say EPC engineering, or it's called red book. And silver book, red book is meant for purpose of contracts devising for exclusively construction contract, where design is given by owner or by engineer to contractor, and contractor works on that based on that contract. And silver is where EPC is involved, means engineering, procurement, and construction. All are involved in that, and that's called EPC. That's called silver book. And also FIDIC is international body that organizes contract forms or contract structures. That's a update is 2017. I talked to length before, but I missed all that. Then there's a QCS that's also related to Qatar civil specifications, that's related to concrete and general and soil, because I always refer to that because I have worked on that very well in Qatar when I was there, and I this is a completely detailed one. I had opportunity to share that information with you. And then is current problem of COVID-19, and also many also all this we can take into our discussion all time together, and the miscellaneous talk can be conducted this way. हम ये बातें जो आपको बता रहे हैं कि मैनेजमेंट क्या होता है, कॉन्ट्रैक्ट क्या होते हैं, और आपका मैनेजमेंट प्रबंध कैसे किया जाए, ऑर्गेनाइज कैसे किया जाए प्रोजेक्ट्स को, कॉन्ट्रैक्ट्स को, और किस तरह से हम क्वालिटी ला सकें कंक्रीट के अंदर. कंक्रीट बहुत इंपॉर्टेंट पार्ट है. कंक्रीट इज ओनली वेरी इंपॉर्टेंट मटेरियल दैट इज यूज्ड ऑन ऑल स्ट्रक्चर्स. Concrete means not concrete exclusively. Concrete means steel also. Concrete means steel tendons also. So concrete, when I say it, means concrete and steel. It's not simply concrete itself. And what is concrete? That's also very important part to know, to understand. Concrete is not very ordinary material. This material is very important material because we use earth material, rock material, original material into our buildings or in our structures or wherever we use this, and that is very important part of this. Until we understand what is concrete, we cannot define concrete. Concrete is not a verb. It's just not simply adjective. It's not simply something to define. It is something exclusively of top importance. We have to give a complete concentration on that. Concrete is the C-O-N-C-R-E-T. You cannot say simply spelling of this, but it's very important part, because if you ask someone to define concrete, everybody will define it in its own way. But that definition is just article definition. Question is, now we have to understand article definition. We have to understand practical application of concrete. That's very important point. Everybody has to understand. Engineer has to see what is concrete means. Concrete is a technology. This is a vast field in engineering. It impacts all. It impacts not only civil but also mechanical, because there are machines that rest on concrete or on something else in form of foundations, and also electrical as well as others, because transformers, switchgear have to rest on some floor foundations. And wherever you say turbine, during manufacturing of electrical engineering, turbines are there, which is part of mechanical, that is on machines or somewhere machine foundation. Similarly, it involves everyone. Means you are sitting in a building where you are software engineer, the building is also civil engineering product, and you are using that. So what I say, basis, you can say analytical basis of all world is civil engineering. Civil engineering is, civil means human. Actually, human engineering, this says. Even if you see how this earth is, consider earth as a building, consider earth as a ball. What do you think? How it's moving is a big question mark. I want to construct a room. I need all designs, and I have to do all work on analysis of that small frame, and also structural design of slabs, beams, and all this complete framing along with foundation. Then I can say I am sure that this building, this small house, a guard house or small house, shall not fail in foundation. It shall resist all forces coming onto this in actions like dead load, live load, and wind loads and earthquake loads and other loads onto this, or thermal energy, or whatever we call it, supersonic energy. All this house shall take, all this building shall take, that we take into our consideration, which is very important part. हम सारी फोर्सेस कोई भी छोटी सी भी चीज़ बनाते हैं तो उस पर सब देखते हैं, काउंट करते हैं, कितना इसका अपना लोड है, मटेरियल का कितना लोड इसके ऊपर आएगा, किस तरह से ये हवा को वापस भेजेगा या उसको सहेगा, किस तरह से ये सूरज की रोशनी सहेगा, किस तरह से ये भूचाल की शक्ति सहेगा, ये सब चीज़ें देखी जाती हैं। फाउंडेशन कैसे बनाएंगे, उसको बाद हम कहते हैं हाँ ये बिल्डिंग अब रह पाएगी। दिस इज व्हाट इज वेरी इंपॉर्टेंट पार्ट इन इंजीनियरिंग. वी हैव टू वेट एंड टेक इनटू आवर कंसिडरेशन ऑल दिस फैक्टर्स. इज नॉट वन फैक्टर. Of course, this goes on moving for whole life of every engineer and others. But sometimes what happens, engineers also forget what they studied in their field or what should be done without even going to reference of books. You have to think. Your mind is like a book. Once your mind starts working on its own, you can think what should be done. It's not necessary all time refer to books for purpose of certification. That is fine. Otherwise, your mind itself is an automatic generating book. It gives you answers all times, tacit answers, improvising answers. You get answers from your mind itself, which is a powerful tool everybody has. It depends upon one's own power, how long, how much, what percentage of mind you are going to use. That point is very important to understand. I'm not saying you're not using, you have capacity to use, you can use. That's what engineering is. Something you cannot define directly, just like a definition of concrete. We say concrete, oh yes, this is concrete. What does concrete mean? When you use it the other way, you say, oh, this work is not concrete. This doesn't mean concrete material is there. Concrete, this work is not solid, this work is not certain. Right? That's the meaning of concrete. Article meaning you can say concrete. Right? Oh, this is, I want some concrete answer. People say like that. Tell me, give me concrete answer. It doesn't mean concrete is no, all their answer is concrete. This means concrete has some word, some meaning, and that is verb, because oh, this is not concrete answer. You give me some concrete means reliability. You know that? Solid answer. Answer on which we rely. We understand what are you saying or what is the intention about that. That's called concrete. Reliability factor means when you say, okay, I'll give you concrete results. I'll give you concrete results. What does it mean? My result will be as such that you can depend on them with safety and with required service or intended requirement of service, and also it can be long journey material or answer or result, which you can give terms of durability. We simply define in our language reliability equal to safety plus service ability plus durability. That's general definition of general minimum definition. I'm saying it's not ultimate definition, it's minimum definition that should be considered while thinking of something, thinking about something, that it's reliable. And reliable means you can again and again go to that for purpose of solution, and that is called reliability, where liability is covered all time, where safety is included, where serviceability is included, and where its milestones of long journey are included, and that is called durability. So if somebody asks you concrete, how to answer that, that's the point. Concrete in general way or concrete in engineering way, what way is required, because I have experience of this, and sometimes I ask one a great engineer of one state, define concrete, and that person was looking at my face, what he's asking, define concrete, can you define concrete? That point is very important. Concrete is not only what we understand in engineering terms or as engineering material. Yes, if I ask you define concrete as engineering material, in that case that's fine. Engineering material, yes, it is engineering material which involves many ingredients, and those ingredients are rocks in terms of rock particle, aggregates, coarse aggregate, and also rock particles as dust or sand or you can say cement. Cement is also rock particle because it comes from limestone as well as silt. So somewhere these are all family members of rocks, and so you can say a kind of combination of rocks itself constitute, or you can say generate, ingredients of concrete, and those ingredients can use along with water in some proportion it goes to liquid form of concrete, or you can say fluid concrete, which has certain limit. Within that limit, if it is used, it can work as stone. In sometimes it will become stone, and if you do not use within that period of fluid state, it will destroy itself, or it will those ingredient material of rocks would not work. And that's what part of technology means. You have to use into certain kind of shape or molding, and that's called structure, along with placement of steel within that, provision of steel reinforcement or something else in some other form. Could be rolled steel, or could be structural steel, or could be in that way you can say tendons, or that's called cables or freeze-dressing, or whatever you put in that in form of BRC or steel reinforcement, whatever. That's part of RCC. RCC is very important point. It's not concrete alone, though we think RCC is concrete, or somebody thinks that concrete is. No, it's not. It's a combination of both. RCC is something which is completely different, but it comprises of concrete and reinforcement, or we call that steel. Purpose of steel and purpose of concrete are different. Both are having opposite properties, because concrete is very good in compression. It absorbs compression, resists compression very well, and it is not that much strong in opposing tensile forces, tension, or you can say reverse of compression. Compression compresses something, and dimension of that one is reduced. You can say if you compress something, you stress it. Stress, we use this here, is stress in general terms, and that's called, if you apply some force on some unit area and you divide that force by that unit area, whatever result comes in, and that's called stress per unit area. So many kilogram or newton or tons per square centimeter or per square meter. While there's something else also, that's called strain. Means by that pressure, if you change dimension of that one, that is called strain. Whatever change is affected, maybe in 0.01% to 0.001% or 1%, whatever it is, that's called strain. So these are different meanings in engineering terms, in applied mechanics or strength of material, or in theory of structure, you can see. These are different terminologies. But when it's a concrete material is involved, because we are saying concrete is very good in compression, but it's not very good in tension, while its family member or its combined member, composite structural member, that is reinforcement we call it. Why do we call reinforcement? That's first point to understand. Why do we call it reinforcement? Reinforcement. There is some force missing. We enforce that within that, and we reinforce that because we put that force back to it, so that that tension which is missing in concrete, compressibility is there, compression is there, full compression is there. We have put good value of compression while you use materials of rocks ingredients into that material, and that's called concrete, solid concrete, hardened concrete. It's very good in compression. But if steel doesn't exist in this fails in tension. When it fails in tension, it's not RCC, it's only concrete. And when RCC is clubbed in within that permanently, then it's called RCC, reinforced cement concrete, or you can say RC, reinforced concrete. Or pre-stressed concrete is also it's called, when you use pre-stressing tendons with this rather than steel bars, the same thing. Those are also more stronger than steel bars, and they work in different technologies, but principle is same. We use wire stresses on those tendons or cables, we call them cables as well. So pre-stressing concrete, it may be, or it may be cast in situ concrete, because when you mold concrete on site, you cast concrete on site, it's called cast in situ concrete. When we produce this in a factory, it's called pre-cast concrete, or also pre-stressed concrete. So they are different positions, different methods, but ultimately it is concrete. So in general term, as a concrete structure, it means RCC or PSC structure. It's not simply concrete alone. When you call only concrete, it's called plain concrete, means concrete RCC minus reinforcement. Plain concrete it is. Plain concrete is not structural concrete. This is concrete some just for purpose of using on removing unevenness in foundation, when we call it blinding concrete, or some people call it lean concrete. So we have to think that way. Concrete is something very, very different. It gives from raw materials, like as I say, rock rock ingredients mixes water to form fluid concrete, and that fluid concrete has certain time to work in chemically, and it works with chemical energies, chemical reactions, and it sets itself into state. Some state is called grain state, and then means from liquid state or fluid state it has into plastic stage. While we allow it to start setting, and then it goes to gradually hardening stage, or after having many days of hardening it becomes hard, it becomes stone like structure, and that's what we can say this is artificial stone. So concrete is artificial stone in that way, and you put in its deficient power of tensile stresses, tensile resistance that is granted to it by steel reinforcement. It becomes RCC, and we call it reinforced concrete or reinforced cement concrete. And as I said, meaning of reinforcement is very easy. It's not that we are using steel, it's called reinforcement. That's we use it for convenience. But reinforcement, something is missing or we have lost something, we have to recall it, we have to demand more, and that's called reinforcement. Just like it happens in military or armed services, there's some deficiency of armed forces on border. They say, send reinforcement to replenish losses. So replacement of losses is also backfilled, or you can say filled in, or you can say made good by using reinforcement. That is actual reinforcement. You have lost something, you have to replenish that. That's a kind of reinforcement. Just like you lose some job, you're suspended, and later you're brought to reinstatement stage. It's a kind of you have reinforced again. So the reinforcement, you have to come back to your force which you are in before losing that one is called reinforcement. This is just general basic definition which I could learn based on my own understanding, and somebody could tell me during my class when I was too young in student of engineering. That time I still remember what my professor used to tell me how to understand this. Doesn't mean for you to think that way. It's just the programming to understand how to remember something. It's very easy to remember. Sometimes you cannot cram everything. Cramming is no answer. Just like we use critical thinking in all professions nowadays. Critical thinking is a part of thinking, how to think of something. That's very important part. If you don't think that way, you lose something. So that's why I tried to explain to you how we think that way. Concrete world is different. It's not ordinary world. Concrete technology has become so widened that itself is a kind of domain, concrete. We people take it easily. We think whatever you see, using your eyes, by your eyes in this world, wherever you go, you find this is concrete or this is construction. You view that, and because you have no background of that, what to think of that, how to construct or interpret that, you will simply say, oh, यही है भाई, यही तो कंस्ट्रक्शन है, ऐसे ही बिल्डिंग बनती है, ऐसे ही कॉलम खड़े होते हैं, बीम बनती है. और लेंटर बोलते हैं हमारे देश में, लेंटर नॉर्थ में इसको स्लैब को लेंटर बोलते हैं. लेंटर नहीं होता है, स्लैब होती है, लेकिन हम मान लेते हैं क्योंकि लोग बोलते हैं तो लेंटर ही सही, लेकिन लेंटर नहीं, लेंटर्न है. थोड़ा बात को समझिए. लेंटर नाम की कोई चीज़ नहीं होती. लेंटर जो लालटेन होती है, यह आपकी छत पे रोशनी दे देता है, आपके ऊपर आपका कमरा बना देता है. उसकी छत डल जाती है, छत जो रोशनी देती है आपके कमरे में, जो लेटे लेटे आप देखें तो छत आपको दिखाई देगी. अंधेरा भी क्यों ना हो जाए तब भी आपको छत दिखाई देगी. तो उसको कहते हैं रोशनी, लैंटर्न. बहुत से लोग लैंटर्न यूज़ करते हैं. यहाँ हमारे मेसन्स तो लैंटर्न, जी लैंटर डल रहा है हमारा. ओके, आई डोंट हैव एनी प्रॉब्लम विद दैट. यू कैन कॉल इट लैंटर और यू कैन कॉल इट स्लैब. रियल वर्ड इज स्लैब. स्लैब मीन्स हिंदी में क्या कहेंगे, छत तो मैं नहीं कह सकता. हाँ, छत कह लीजिए, मान लीजिए आपको समझने के लिए. सर के ऊपर कोई चीज़ परमानेंट, समथिंग ऑन योर हेड इन फॉर्म ऑफ permanent material or permanent member, and that is called slab. We call it slab because this is not perfectly vertical, this is perfectly horizontal or sloped in, and we say slab. Actually this is not a slab. In design word we call it diaphragm. Diaphragm, that is design word, diaphragm, diaphragm, which is meant to stay horizontal and resist horizontal forces. Its thickness is much less in comparison to its length and width. If you measure length and width of this member slab, it's many times. Let us say it is 10 centimeter, 100 millimeter, 125 millimeter thickness, or it may be 150 millimeter thickness, but length may be 10 meters, 5 meters, 4 meters, or it may be 3 meters width, 4 meter width, 5 meter width. So 10 meter, 5 meter and 0.15 meter are much more varying. You can see there's a big ratio difference in dimensions of that slab and thickness. So it is a very thin member, we can say. It's like a steel plate. Lamina, you can say. Lamina size lengthwise is very long or widthwise is very big, but if you say thickness of that is very small. So it's like sheet structure. So it's not exactly sheet. We cannot say exact sheet because thickness is still considerable, because 150 mm or 100 mm or 125 mm in comparison to sheet structure, that's not that much. That sheet is very flexible and it may be 1 millimeter, 2 millimeter, 1.5 millimeter, not more than that. 2 millimeter maximum, and you cannot just compare to that one, but we use name as it is slab, or it is diaphragm, or it is thin plate, you can say, just for purpose of using that article. It doesn't mean that it's a thin plate, but because it's resisting vertical forces on that, means it's first resists its own load. Slab concrete has its own load, and for your information I'm telling you, because you are talking to common public, weight of concrete is 2400 kilogram per cubic meter, and we measure it along with included steel within this. We just consider for purpose of design 2500 kilogram per meter cube, and meter cube is 1 meter by 1 meter by 1 meter, that is meter cube. So 2500 kilogram per cubic meter is density of concrete, or you can say direct load of that. So that is that load, we call it load, that is permanent, that cannot be varied. You cannot vary dead loads. Dead loads are those loads which are material loads. It can be concrete load, it can be wall or brick load, it can be stone wall load, it can be whatever else load which cannot be changed till that the structure works, and even after that the structure is demolished or dismantled, weight still remains same. So this 2500 kilogram per cubic meter has within itself stone aggregate, coarse aggregate, dust, or you can say cement particles or cement contents, or there's water within this, and steel. So this all comes in this. In just it comes, we contemplate that we take 2.5 tons, now it's using tons per cubic meter, and that's where it works. So based on that we can calculate what is thickness of your slab, and per square meter it should give that much, that load which we take into our calculations. This is one part of design. Other part is those loads which are not permanent in this load, which keep every day changing, every hour changing on that surface on which this slab is laid. Weight, when you walk on this, weight when you stand on this, you keep your goods on that, and you keep something there, and you say whatever variations of load to come in there, actions come in there. Load also is called action, forces are also called in actions in European codes. So we say yes, these are live loads, loads which are live loads which have no guarantee. We say live telecast, we call it live telecast, just like I'm talking to you live now. That's called live load. Load which keep on moving from time, all minutes, all seconds, all hours throughout life. These can be removed, that this can be brought, and these can stay there for few minutes per hours, and they can be moved. You can say you can shift your goods from this place to that place. You can walk, you can sit, means all those are called live loads. And there are certain loads which are accidental loads as well. Accident due to whatever reason, seismic load, or you can say thunderstorm load, or whatever load which do not have any guarantee, or you cannot ensure which time it would impact on your building. Those are called accidental load. And there are some load which are, you do not know how shall they behave. These loads are also there. Transient load, we call them. Fire, say for example, accidental load is there on building. Thermal heat, thermal heat is a routine one. During hot sun, you get thermal transmission through your buildings, through your glasses, everything. That's all is considered into our design criteria. I'm not going to tell you what is that, just I'm trying to inform you how we live, how we design, how we make them good into field of that's called construction, production, and that's what it is. So when I talk of these materials are not simple materials. These materials are technology-based materials. Heavy technology is involved behind them. These technologies common people cannot understand because there's a big gun behind them. We have to spend a lot of time after having educated status, and we have to learn it for long and throughout life. Even then we cannot say that we have got expertise in that particular field, and that is what concrete it is. You can say concrete is used on airports, on runways. Also, it is used in buildings, it's used in foundations, it's used in pilings, it's used in rivers, embankments, or in you can say many other locations of you can say harbor. It's used you can say in canals. It's used in many other structures, and there is no limit. Concrete has no limit. It is only material that can be molded and remolded. It has certain property that it allows to take shape wherever it's poured in, and that's very important point. Means this is very much reliable material because in whatever shape you put it in form of formwork, and it goes there and does its work in that way, which depends on design of that structural shape which you want to give to this concrete. So do not take concrete as it's like potter work. What potter does. Potter gives shape after preparing that clay soil into its workable form, into because of workable concrete, workable clay. That potter, though it's very small structure, but structure is structure. Potter produces pitchers, potter produces surahis, jugs, many other small items. These are all pottery. So there's no reinforce in them, but some materials may be there. So engineering concrete, you can say it's like pottery work. It's not pottery in exact sense because we are not producing pots, we are producing buildings and structures, so structure is pot here. You can call structure pot, though it's not used, I'm just joking for purpose of refreshing that there's no difference in that. Only difference is that is traditional, that is clan work, but this is professional work. Though that's also professional, I cannot exactly condemn that because profession of the potter is pottery, and that is livelihood by which that potter lives in, makes life. Though it's not demanded that much, yet that is respectable profession or occupation, I can say. But this is science, this is engineering, this is technology. This without learning, without achieving, without understanding thoroughly, we cannot do it. There is a subject we call theory of structure, and before that was applied mechanics. Applied mechanics has limitations, but theory of structure is unlimited. Why we call theory of structure? Means we are going to talk of structures, right? When we say theory of structures, that subject involves structures. That is very much true. And while we say applied mechanics, that is limited to material arrangements, material properties, understanding, application of, you can say, mechanism. Applied mechanics, we say there's a mechanism which exists between various materials and materials on own way with other surfaces, how it behaves, how it conducts, and that's called applied mechanics. So various terms are symmetrical, like stresses and strains and Young's modulus. When we divide stress value by strain value, we got Young modulus value, and there are so many other terms which are used in mechanism, and this is also a kind of refined applied mechanics, and we can say that's theory of structures, because theory of structure is also nothing but a kind of mechanism. Every structure is designed by certain mechanism, and once it is designed, it works as that mechanism. वो एक बार हम डिज़ाइन करने के बाद कोई भी स्ट्रक्चर बना देते हैं, वो मजाक नहीं है, उसके अंदर कोई ना कोई मैकेनिज्म तो है, मशीन तो है, वो एक मैकेनिज्म। व्हेन आई टॉक मैकेनिज्म, दिस मीन मशीन। हम जब मशीन की बात करते हैं तो मैकेनिज्म सामने आता है, जब मैकेनिज्म की बात करते हैं तो मशीन सामने आती है। वी हैव टू अंडरस्टैंड दिस पॉइंट वेरी क्लियरली। आई एम नॉट आइसोलेटिंग माई सेल्फ इन दिस, आई एम कीपिंग इट विद वर्ल्ड, because mechanism works in every structure and structure creates mechanism. They are both two, and this way and this way you can say. Without understanding mechanism, we cannot create structures, and structures create mechanism also. Maybe sometimes what we think it would work, it may not perform that way, but it should remain stable, it should remain working, even though mechanism may be different, practical mechanism or virtual mechanism may be thread, but it works, it performs, it survives. That's important. It doesn't matter when I design some structure and say whatever consider my contemplation, my consideration, all criteria I've taken, shall it behave according to that? I cannot guarantee that. But one thing is guaranteed, that it will live, it shall become unit, and not that this is column and beam and slab or this beam and the van. All shall work in unison. That is more important. All shall work in unison. Take example of a stool. You know, stool, what is a stool in your room, in your home? You may be having small stools which is very small plate of 1 foot by 1 foot by 1 foot and height, say maybe 1.5 feet, and you say it has 4 legs and there's a top slab and some beams at bottom, small timber beams at bottom, and you say I stand on this and I don't fall. That is what is required. Stool is required. It's not a question that here's a slab, I'm using this slab. No, you are not using a slab. You are not using columns. You are not using ties. You are using that stool. Stool. That is unit member. So we have to think not in elements but in units. When I call unit, doesn't mean measurement unit. When I call unit, it means body. It's the body of this. Building is a body. The structure is a body. You may say it's airport, but building of the airport is a body. Body. You may say, oh, this is a multi-story building. Yes, but it's a body. You cannot use breaking it into 4 pieces in the same way can you use? You cannot use. You have to use them in unison. Even one room is used, or one story is used, or whole stories are used. These are used in body form, in structural unit form, and that's when I say unit. It's that unit body. What engineers do actually, we think that way. Think that way means it's not one sentence, I finish, I think that way. No, it's not that. This is simply talking. This is simply statement I'm making, but behind this lies a lot beyond a common person's imagination, beyond that. Some people even don't know what's behind. They only know what they see. That is engineering. No, my dear friends, that is not engineering. That is product. It's product. What you see on fields, on sites, some construction work goes on, it doesn't mean that is true one. That is only production organization. Behind that production organization, there are many organizations that contribute to that production organization. You think in that way, this engineering is also factory, it's also amounts to industry value, but people do not realize. You say, I do myself, I know how to do it. You know because you have seen something being done. More than that, you do not know. And that which you do not know is more important than what you see is being done. What's being done is something where no mind used except mind required for purpose of producing that, for purpose of construction activities, not more than that. But behind that, 95% work is done behind that construction activity. 95%. I agree 5% activity can be given to what work is done on site, but behind that is a lot of work about which common people who are non-professional engineers or non-engineering people, they may not know that. It is something machine, you buy a machine, use a machine, or say I'm using machine, it's working very well, but you never think of, you think of how it was produced, how it was done, and that is, as appliance you are using this, as machine you are using this, but there's a lot of work done behind that during its designing and production, and before that during extraction of materials from ores, where ores were extracted out from earth, and then chemical work was done on that in form of, you can say, converting that ore into material extraction by process of chemistry, by process of planting. So what I'm trying to say, do not just decide based on what you see. What you see is different. For example, I see, oh, beautiful young girl and handsome boy. We say that. But ultimately, why we say? Because our eyes please, oh, what a person, this is smart guy. We only see his height, face, and how body language speaks. But we don't know behind. Behind there is same, everybody is same. If I remove skin, what's left? Can you view that? You can't. Oh, it's horrifying. Yes, that is horrifying. If your skin is removed, your skin gives charming of your body, your eyes contact, your nose contact, your lips contact, your mind contact. Ultimately, mind contact is most important, remember. Without understanding minds, you cannot understand a person. You cannot finalize your decision based on some person, based on eyes contact or some other contact, except mind contact. Because when you understand what mind this person has, then you finalize actually what relation you can build with this person. आप किसी के साथ क्या रिश्ता रखते हैं, ये उसके मस्तिष्क की सोच पर रखता है, उसकी सोच पर रखता है कि वो आपकी सोच कैसे मिलती है, आपकी सोच उससे बहुत ऊंची है या उसकी सोच उससे आपसे बहुत ऊंची है, आप किस लाइन तक उससे मिल पाएंगे या नहीं मिल पाएंगे, आपके ऊपर है. It depends upon you how to correlate thinking of that person, and that thinking is very important. That cannot be measured in terms of forces, that cannot be measured in terms of length and width. It has to be understood what degree of fighting power, what degree of absorption power, what degree of thinking power, what degree of logic power, what degree of reasoning power person got in. And this depends, same thing applies to engineering. Engineering itself is science of thinking, science of thinking, science of analyzing, science of using analytical answers to synthesize that. And this is science of physical work, this is science of mental work, this is science of thinking, science of rethinking, science of giving soul back to sometime used structure which has used itself, which has even brought its matter to its hysteresis stage, a stage where we can say it has been used to its maximum extent. Now we want to enthuse, we want to inculcate more soul power into that, so that we can extend its remaining life into many times more years, and that's called retrofitting. I'm not here to tell you what these definitions are. I'm just trying to advise you, engineering is different. Do not consider product as only engineering. Product is just a material to be used. It's user's valuable product, but behind that, it's not only that product, but lot of production mechanism, lot of design mechanism, lot of everything. You think, oh, this is a lantern and run it, you are happy, but you don't know what lantern is, how it works. If I say your lantern is bending, if I say your lantern is bending, you shall not believe it. As non-engineer I am talking. If I say your lantern is bending, is trying to come down, you say, what nonsense you are talking? You want this lantern to fall? No, it's not going to fall. It's not designed for falling. But why I'm saying, now my question to you is, I say, okay, I don't give you steel, You say concrete is good material and lintel stays, alright. Make lintel without steel. Make it. Just put concrete there and come out. Remove shuttering after whatever number of days and see how it works. What you think? Shall it work? Shall it work? You will come to question how it is possible. Yes, that's what I say. How it is possible. That is what I expect you to answer me. How can you say it would work with steel? This means you know it works with steel. Because you know. If you don't know, then if you don't know it works with steel and I give you, okay, this is concrete, this is your work ready, pour it, and then after striking or removing shatters of formwork, you use it. You say, what sort of question you are raising? It's not possible. This means there is something else you need. Either that structure which you built in concrete without steel, it will crack in, it will drop, or it will not work. It will come down or bend. I am not saying structure with reinforcement won't bend. I am not claiming that, remember. Not at all. When we say bending, it's very big question. It's very big consideration. You know, people do not know how these elements, we call them members also, you can call them columns, beams, slabs, and like that, whatever foundations, these are all dominated by bending. You'll be surprised to know that, but this is fact. If you say there is no bending, then structure is nothing in that case. If you say what is bending, actually bending is important for structure, and if the structure doesn't bend, then there is no need of any engineering science. This is what we handle. We treat bending of all members of structure. Bending. Ordinary person who works on sites, if not engineer, then for him bending, or you can say many forces are there in that. Those forces do not have any meaning, because that person only knows what that person sees or what that person has worked. But life is not that. Bending. If you bend something, what shall happen? Think of. There is a rod, you bend it. Or there is a brick, you take and bend it. Or you can say, there is a stick, you bend it. It's common activity. You might have done it in your life also, but you never noticed. You have done. While relaxing, sometimes you have some timber piece with you and just trying to bend it. You did that, but you did not understand what was that activity. How you did it, why you just did it. Just like I bend my hands. I rotate my throat. I say that. I'm relaxing myself, I'm stretching my legs. Yes, that's right. Just think of, my body is not rigid. Why? Is your body rigid? No. But there are so many materials which are rigid. My body contains blood, my body contains flesh, my body contains bones, my body contains liquid. And I bow down, I hands up, I can use my arms, I can walk with my legs, I am speaking using my lips and tongue and mouth. I am respirating. I am using my eyes and turning them this way and that way. I am using my shoulders like this, and I can dance also. What is that dance? You dance, right? If you are rigid, you cannot dance. You cannot dance. If you do, you fall. If you do this way, you fall. But no, I can dance, I can jump, I can walk, I can talk. Right? What does it mean? This means this body is structured flexible to lot extent. Flexible. If you just touch your body and see, you can club up, you can raise your skin without tearing up, and again it goes back to its original position. I can raise my hands like this for long and it can come back down. It doesn't stop there because I raised it, it will come down. This is natural phenomena. This means this body is designed like that. That this is not rigid. And we live in this forever. We do all activities in this flexible body. We eat, we respire, we see, we walk, we jump, we sit, we do, we speak, we run, we don't run, we exercise, we do everything with this. We fight also. What do all these activities convey message to us? ये सब बातें क्या कहती हैं? कहते हैं पत्थर है ये आदमी. कहते हैं ना, ये आदमी पत्थर है. हम सब पत्थर ही तो हैं. हम सब पत्थर ही हैं. We all are stones. But flexibility degree varies. Patthar, stone, very strong it is. I can't break it. Oh yes, it's less strong. I can use hammer and break it. The same stone becomes a soil. Same stone becomes a peat. Peat is also a kind of soil. Same stone becomes dust. Same stone becomes coarse aggregate, small pieces in stones. Same stone becomes lime particles. This means there is a variance in flexibility of stone. This means stone is also not permanent in its conduct, in its properties. It changes, it keeps on changing. You have to understand that point. Our body is same. Our bones are very strong, but our heart is not very strong. Our flesh is not very strong. My head is stronger than my legs. My legs are stronger than my stomach. My stomach is very weak. My chest is more stronger than my stomach. My eyes are very soft. My cheeks are very soft. My lips are very soft. My elbow is strong. My fist is strong, but my fingers are all strong. My palm is strong, but this part is not strong. I'm sorry, my palm is not very strong, but this is strong. Means whatever property, whatever value is required for some activity, this body is designed according to that. Whatever is required to speak, that softness, power is given to tongue. Whatever way is required for whatever activity, that has been put in your body. So this body is an example of flexibility, and same body is body of a freestyler, or you can say wrestler, who has built body, who has built the body to that extent that he has more resistance than an ordinary body. So I say this body is a combination of various structures: head structure, face structure, arms structure, palm structure, chest structure, you can say waist structure, stomach structure, then organs structure, and then you can go down to leg and knee and all feet. All structures constitute this body into human body. And all animals do have similar kind of properties with them. Just think that way. So God has done a lot of engineering designs behind production of this body. So what engineering name you can give to this? Human engineering or human body engineering? It's up to you. Don't forget, we have a body. It is a system, many combinations of many systems into one system, and flexibility degree and rigid degree, both. And also electrical power is there. You know that? That's called soul. Electrical power, electronic power, electromagnetic power. Every body has from birth time to death time, and this gap, this duration of hundreds of years, or you can say whatever many decades you live in, you enjoy this body. You need not throw this body to change it or replenish it or reinforce it. Automatically it happens throughout. So what a mechanism it is. Do you understand that? Can you understand this? Or I think you must understand. आपको समझना चाहिए जो मैं बोल रहा हूँ. बड़ा सिंपल लैंग्वेज में बोल रहा हूँ. इससे ज़्यादा सिंपल तो आपको बताएगा भी नहीं. This is structure of body. Total structure. There's bones structure. There's intestine structures, anatomy of body, and then so many and so forth, which I can't know, I don't know. But there are so many institutions working in this body. Head is an institution, eye is an institution, face is an institution, heart is an institution. All who are very responsible for this body are institutions. And doctors call them multi-organs, but I am speaking different language. I am speaking not that language which is doctor's language. I am speaking to understand whether or not this body is a structure. Yes, this body is a structure. Because it always remains in stationary equilibrium as well as in dynamic equilibrium. When I say equilibrium, it means स्थल है, गिरेगा नहीं. ऐसे ही रहेगा, गिरेगा नहीं जब तक ये खुद ना चाहे गिरना. Equilibrium it's called. I don't know actually Hindi meaning of that equilibrium is, but no problem. We call it static equilibrium. वो equilibrium जब आप हिल नहीं रहे, आप शांति से बैठे हैं और मोशन नहीं है, डायनेमिज्म नहीं है. And when motion है, it's called dynamic equilibrium. Stationary or static also it is called static. State, one state is there and you are in that state. You don't change that state. It's called stationary, because that is station stage where you have stationed your machine, and that is station stays stationary. But when you move, it changes from stationary or static equilibrium to dynamic equilibrium. So our body is both. It enjoys both states of station, or you can say static equilibrium, as well as dynamic equilibrium, or you can say movement equilibrium. So if I'm dancing, I am not falling. By error, by accident, I may fall, that's different. Am I walking? I'm running. When I run, I walk. It's also a state of equilibrium, and that is dynamic equilibrium. And now when I say, let's enjoy, or somebody is doing something, somebody is exercising, some performing something, means wherever you are, or you are meditating, I'm just sitting in there, I don't know what. All stages enjoy state of equilibrium. All enjoy. So same God's, we are copying God's thoughts when we go to structures. Our body itself is a structure. I saw some engineer long back. He was, I think, Italy or which country. He had designed some architecture of a bridge, like as if dancing in one mode, and that mode was given to that bridge. And then questions was asked, why to say? He said, when I am in equilibrium in this position, this can also be in equilibrium in this position. So that's the best way how to learn something, by your own intuition. Everything cannot be extracted from books, because books are also written by human beings. So you either write or you do something, that's all book. You think something, that's all book. Yes, until you think, it's in your mind, but it's somewhere available in your aura. And when you bring it to papers, it's called writing. It's called work with your mind, but you bring it to some paper or software or somewhere on computer and you say, I have done it. And that is called writing. So why I am trying to say to you this is because I am trying to explain to you the structure, which is very important part without which life is nil. If you don't enjoy structure, you cannot live in a house. You cannot live in a building. You cannot walk on road. You cannot do whatever you want. Even your flight, your aeroplane is a structure. Do you know that? It's complete structure. Many sheathed wall of aeroplane, many sheathed wall, many layers of wall, many layers of glass windows. You see that? That's also structure. When you stay in your home and you say, oh, outside temperature is very low and inside temperature is warm, because that your structure walls and your structure envelope would give you, a difference of temperature, and that you enjoy. Maybe outside is too hot and inside is not too hot. There's reliable difference, considerable difference, and it's because of material conducive power or material resistance power that you have used in your building. So I was talking about slab. I cannot go back until I resolve that talk. That slab which I was calling in bending, and you were surprised at how you're talking, how it can bend. If it bend, then I can't sit on that. That's right. That's very right. Your counter question is very right. How you can sit on that? You can't sit if it bends, but it's not going to bend to that extent. It's not going to bend to that extent. It's going to bend to some extent, not to that extent. To some extent. I'm stretching my legs also. Because already 1 hour gone and I do not keep my legs stationary because of what problem I am facing. I'm sorry. When I'm stretching, some gases was trapped and is now entrapped, is now released. Well, I come back to talk. When we say bending, see, in our terminology, we say this is direct load. Direct load. Direct load means that, see, every diagram, you may say in simple terms, I should say, we call in our language sections or dimensions or whatever. But in your way, I say how to explain to you. For example, I have to explain to you in some way. Let me use my stick to explain to you. I think that is better than something else. Okay, let me use this stick. If I take my stick down here, I did not show you that stick here. I'm using for my purpose. That stick is here. Let us say this is a stick here. This is a stick here, right? You can see this stick is here. It's working. And here I'm using it for you, so I'm just referring to you. Let us say this is a column. Let us say that this is a column here. This is the column here, and of course its shape is like this. Don't assume this. Let us say this is a column. Some load comes on this. Say load is coming on this. There's a shape of this here. Let us say this is a column. Size of this is square one or rectangular, whatever it is, don't worry about that. And let us say like this, it's here it's a column. I give better idea. Now I apply load onto this. If I apply load onto this in its central line, which we call axis of column, if in this central line means center of two diagonals of this section or this size, I apply load here vertically, that is called axial load. Load that is applied at center point of this, and it is called direct load. When we apply here load, it spreads in this area and it goes down. That is one part of load which people understand. That is only load. That's not true. That is not true. Now let us say that I apply with this load. Here is a slab or beam, let us say. All of this, let me take it off back. Now let us say in different terminology now that I apply some beam here or slab here. Let us say this is a beam or slab. Now this beam or slab shall transfer load onto this column, but because this I have connected here, it's not free. I have connected here. So when this is connected here, this load first is here, then it comes here. So this first will try to bend this beam or slab. When this try to bring it down by force, this will try to pull up, right? Got my point? So I'll say what I'm saying is, this is fixed one. This is fixed one, right? And I'm applying load here. When I apply load here, this first will impact on this member, then it will go there. When I apply load here, this will pull it down. It's forced to go down. When it goes down, it will come up. Got it? When it goes down, it will come up. So it will try to pull this column up. This, when we push it, it goes down. That is called sagging. S-A-G-G-I-N-G. And here it goes up from this position. It's called hogging. That's what I want to tell you. Now I explain to you what I said this. You can consider this foundations. This is not foundation, you can consider. So this is your column and this is your foundations. Alright, now I just showed for purpose of making clear, otherwise there is no link to that foundation or that stake. Now when I say I was talking about slab, first of all, that slab is not resting on ground. When you walk in your street, you will find concrete path. That is also slab, but that is resting on ground. So you cannot call that slab suspended slab. There is a term we call suspended slab. लटकी हुई slab, लटका हुआ लेंटर. आप लेंटर तो समझ रहे हैं, लेकिन आप ये नहीं समझ रहे लटका हुआ है वो. You understand what is a lantern or slab, but you do not understand how it functions. Your road or your footpath on which you walk, and if it's of concrete, if your road pavement is of concrete, it's permanently on ground and there is only reaction from ground, otherwise there is nothing. It's only concrete, like flooring. Just like your floor is, it's same thing. But your slab is not resting on ground, it's resting either on four walls of stone masonry or brick masonry or block masonry. Or this is resting on beams which are further resting on, columns. Either these. In whatever case you consider, whatever case you take into your value, this slab or this lantern is not fixed on ground. It is fixed either on beams or on columns or on walls. So when load applies, its own load as well as those who use it, those actions come into play. This lantern tries to come down on all its areas, and it tries to come down to some extent. Sag means from its real position it tries to go down by a few millimeters. That is called, in one way you can say, that is deflection. It has changed its position at various positions, means there's a maximum one at its midpoint, and if you shift to go to beams side or near your wall, it will be less. So there is a 3D movement of this slab into sagging or hogging in both cases. It is 3D change. It's not one dimensional change or two dimensional change. It is volume change temporarily until that load applies. Until that load applies. But remember, dead load is permanent. So dead load is permanent means there are chances of permanent sagging as well. And there are chances of temporary sagging because of additional loads like live loads, as I said. So lantern is also a structure, you can say. Even if you do not fix on ends, you leave them free, then sagging will increase further, because on ends hogging reduces sagging, but hogging is there. Hogging means upward movement, sagging we say downward movement. So where columns exist or where walls exist and your lintel or slab is continuous on many areas or many, you can say walls, many parallel walls, it is continuous slab or continuous lintel. So there are many times saggings as well as many times hoggings, and which is actually called bending. Bending, this is slab bending. This is slab bending, which is not acceptable in terms of stability, but it happens and we provide resistance to that to maximum extent, and that resistance we have to provide. So what happens when bending is affected? Bending results in bending moment. When loads results in bending, bending results in bending moment. So it is another force in addition to direct load. I explained to you direct load, but that direct load is not adequate. There is a direct load on slab also, on lintel also, but that direct load is resulting in deflection as well as in bending moment. So this bending moment is not acceptable. This bending moment is not acceptable to your slab or lintel, because this cannot digest that one. Your slab or your lintel cannot digest this bending moment. वो इसको हजम नहीं करेगा, उसका नेचर वो नहीं है. वो स्लैब हो, बीम हो, कुछ भी हो, कॉलम हो, वो उस बेंडिंग मोमेंट लेने के लिए पैदा नहीं हुआ. Understand this point. You have to inculcate, you have to provide some support to these members, being column, slab or whatever these are, that these bending moments do not harm them. This bending moment which I am talking about, in addition to dead or direct load, these bending moments do not cause any harm to structures of elements like beams, columns, slabs or whatever is there. It's very elementary talk I am making like kids. That bending moment has to be digested by some members' capability, so that it doesn't harm it beyond certain point. For that purpose, we provide a resistance in that member, a resistance or digestion capability in that member, until that bending moment remains, and we call it moment of resistance or resisting moment. There is a bending moment, and to equalize that or to neutralize that bending moment, we provide resisting moment in every structure. It has to resist that moment, which is dynamic force, a kind of dynamic as well as static force. You can see to some extent both ways. when it is removable, or if it's not removable, because dead load also provides bending moment. So dead load, it cannot be removed, so this is static bending moment. And when there's live load, it also forces into that member bending moment, and that is, you can say, live bending moment. Your linter cannot work if you do not provide this resistance to digest that bending moment. You cannot diminish that bending moment, you can digest that. That's only way. And that is what we do in all structures. Means one is direct load, as I said, that's not very harmful. One is bending moment, that is very dangerous, because deflection results in that. Deflection is the second issue, we'll talk of that, but bending moment is very important in all structures. If structures are in danger, these are of undue bending moment, or you can say out of line bending moment, or you can say bending moment due to any way. These are very dangerous, because these cannot stay at one place. These keep on moving from one joint to another joint to another joint to another side, this member to that member. These are very gaming moments, very, you can say, troubling moments or troubling forces. That's what is important to understand, which generally people do not understand. On all these professionals or vocationals who engage themselves on building construction or structural construction, they may be artisans or contractors or builders, they do not understand, they do not give any value to bending moment, which is very critical term in structural engineering. It applies on every member, vertical member, horizontal member, diaphragm member, inclined member, whatever member is there. It relates to many other properties of members. It's not simply bending. Bending only, it goes to torsion, it goes to this side movement or that clockwise movement or other clockwise movement. It goes to cracking also. It goes to destabilizing building or structure. Means it's not simple one part of member of a building, one part of member of one building or one for you. You say I deal with like this. No, it's not that, because we design framing. You know what is framing? I try to explain to many people, but they do not understand. Just like I gave you an example of a human body, which itself is a framing. It may not be rectangular framing, it may not be square framing, it may not be signed awesome, curved. It's a complete systematic framing. Anatomy, which you understand, anatomy and medical science, that is complete framing of bones in certain way that each from top to bottom, all body organs of body parts are in one way or other, are connected and coordinated together, or linked together, jointed at flexible level and joint. Otherwise, same thing is building or structure or whatever it is, that it has to coordinate with each other, it has to talk to each other. Otherwise, they cannot function as a processing plant, because our body is a processing plant. You have seen processing plant like refineries or like manufacturing units, or like you can say steel plants, or you can say something else, aluminum plants or whatever you might have seen, but this body itself is a plant. You may not agree with this, but it is. Sorry. Body is master, you can say top master processing plant. It is such a vast processing plant, you cannot imagine at all. Such a processing plant has been developed in this small body of a baby to old man. Without any electrical requirement, this plant works. It doesn't need any software, it doesn't need any hardware, it doesn't need any electrical supply, but it works. and it works without stoppage. There is no pause. Till you live until you die, no pause is required. It goes on working and working and working forever until you leave this world. Even during your sleep, your rest period, this continuous work. Mind never stops. Respiration or breathing never stops. Eyes work never stop. Heart never stops. Our blood circulation never stops. But we sleep. Do you know what I am saying? It's something miraculous, extraordinary, and we have to learn our life from this. We have to learn how to behave, how to conduct, how to understand value of time from performance of our body, which performance is also not your effort, it's built in performance, it is blessed performance. You have to think that way if you really want to generate knowledge, if you really want to understand what is genius. This is what is genius. You have to produce structures like that because all structures perform continuously. If I ask you, oh, this structure is performing very well, you say, what it is performing, I have done it, is there, that's all, it's that body. No, it's not. As I said, direct load is working. Bending loads are working. Are they working or not? Every member is busy. Every member is busy. Member from foundation to top of your building, all are busy. You may not know that. Just like the machine is working or not working. When electric supply is on, machine is working. But even when electric supply is not on, machine is working. Of course, not for your process. It's on process. Just like our body, when we sleep, it works. We don't know that. We eat food, where it goes outside, digested, we don't have process. But medical doctors also know limited one, not thoroughly one. They know medical processes, but they don't know natural processes. So we have to link understanding of our body mechanism to structural mechanism. When we say this building is in operation, this doesn't mean that what you think is in that operation. It is in operation means when all structure is completed and there is a limit, we say now it has got its own required strength which is meant for it for purpose of a smooth working or servicing its clients or its user occupants. That stage we say operation stage. When it has been given complete power to work, power to serve, that stage is very important, and that stage is that this building is over and it has been given enough power that it would stay there successfully till its working life simplest, and once working life, or you can say durability of this project is reached, at that time, before that we can say we can retrofit it in so that it is extended in its durability and we can use it further. That is what structure is. Don't underestimate structure, and also don't interfere in structure. Interference is very dangerous. Means there is a complete unit equilibrium. I again say unit. Don't consider structure for learning, it's okay, but not for practical work. You cannot say I designed this column and it's done. No, it's not that. Not that. Name is column, name is beam, name is slab, but functions are same. We call names because we have restrictions in understanding. We just want to understand. But it is framing. Framing, three-dimensional framing. Three-dimensional framing. Had there been fourth dimension, I would say fourth dimensional framing. But there is three-dimensional framing. Every unit of a structure works in unity of corporations or contributions by all its members. Otherwise, it cannot work. If one member is interfered with, or if one member is taken out, then it cannot work. Remember, it's like our body. If my one part goes away, I can't live comfortably. My body also cannot work in same way because of destabilization of one part and its negative impact or adverse impact on my body part or whole body. Because my body has been designed from whole to part, there are two ways of designing something. One is design by parts and by parts and reach or make one body by assembly, and other is just start all parts together and design them in parallel to reach in common behavior. So whole to part is basic principled understanding we should have. Whole to part. Do not interfere in what is already done. Some people overact, they smart, they think they can do anything and they can poke their noses into that working structure of building or structure here. And results become that you destabilize that building or that structure and it cannot work in that way after you destabilize and add more to that, until you understand total behavior of that structure or conduct of that structure. It's not joke. It's no joke. It's something very interesting because we have to understand what structure wants and what structure tells, what structure speaks to you. Though it's not going to speak through tongue, it's going to speak through its own performance of its body of unit, and you have to understand how that unit performs, how that stool technology performs. When I am saying stool or table, this table example, now I'm talking to you as my laptop is sitting on this, and this also is stool. If I use it as stationary, I can use it stationary. If I just vibrate it, it will become timely for time being, in dynamic equilibrium it should be. And if it cannot resist that dynamic equilibrium, either it will collapse or it will break into pieces or it will remember itself. So what I'm trying to say is structure is our body and structure is elsewhere. If my body is inbuilt and all organs of this body function, all parts of my body function according to their requirement, same way structure should function. We have to think structures this way. We cannot simply say physically. No, don't think it is physical. The structures are always live. Otherwise you may say, oh, there's one column, I apply load onto that column. How can you apply load to that column? You just construct one vertical member, column. You call it column or pillar. You will generally call it pillar. It doesn't matter, pillar or column. Column is column. Can you apply load on that? You cannot apply load on that. You just do a beam. Can you apply load on the beam? You can't apply load on the beam. Okay, construct column, beam, apply load. Except that load, I say, no other load can come on that. Just erect one column, erect one beam, or other column, apply load. You can't apply. Yes, that load or beam shall come to column. That load for column go down, but no other load. This means you cannot apply usable load onto that structure of column and beam. Only dead load is there, and dead load is dead load, that is not load to be used except for survival of those members. So why I am telling you this? Because it is very much interested for you. It should be of interest to you. It's very much useful in understanding. When you understand your body, and you know body pains if you pinch it, same way structure pains. Structure is not ordinary phenomenon. It's very simple but also very complicated. In this way or that way, that point we have to understand. Once you understand that point, that you will know that house in which you are living is a machine. It is speaking. It speaks. It tells you something. Don't just compare your house on finishes. What sort of finishes you have? Beautiful marble floor, granite floor, or this wall lining or that wall lining. Forget all those first, because those will stay there to perform only when structure is durable. If structure is not durable, you cannot get that performance from your structure as was intended or you expected. Do not go to quantity or something without understanding requirement. I am not here to tell you how engineering is done. I am here to explain to you in this talk what actually you should understand. Yes, it is right that structure has certain elements, certain members in vertical position as well as in horizontal position, and of course sometimes in diagonal positions. There are. But they have certain functions, something. Now, if there is only, say, direct load on building, then there is nothing in building. Means it's so simple. Your small column size can take it. How I can say? Let us say one column is 20 centimeter by 20 centimeter. Let's say this is 20 and this is 20. What I mean to say, section of that here. Let us say this is column. This is 20 and this is 20, which is 400 centimeter square area. 400 square centimeter area. You know that. Concrete can take 50 kilogram per centimeter square. 50 kilogram per centimeter square. I'm just giving you very, very simple terms. This means column, if it is 20 by 20 centimeter square, 400 centimeter square, and if you multiply by 50 kilogram per centimeter square, 50 into 400 is 20,000, right? 400 into 50 is 20,000 kilogram. It can take 20,000 kilogram, which means 20 tons. Very small size, 20 centi by 20 centi. It can take that much load, but it is direct load. And on top of that, you are adding steel also, so that will also take more loads. So in that case, your very small column is okay. Oh, you can take how much slab load is coming. For example, you have a let us say 3 meter by 3 meter slab you have. 3 meter by 3 meter slab you have or lintel you have, and there are 4 columns on that below that. So 3 by 3 means what? Because this is square, so we can say 3 by 3 is 9 square meters. 9 square meter is load of that. And if you take 1 square meter, how much? If you say concrete is 2.5 kilogram per 2.5 tons per cubic meter, you say that way. You say 3 by 3, right? 9 square meter. If I say it's 9 square meter, and if I say it's, let us say thickness is 10 centimeter. I'm just assuming, don't say it is 10 centimeter, but let us say 10 centimeter. 9 square meter and 0.1, you have to multiply with that. So 9 square meter into 0.1, 0.9 cubic meter. It is 0.9 cubic meter. Let us say it is 1 cubic meter. Forget 0.8. Let us say 1 cubic meter. 1 cubic meter concrete is coming on that. And if you are just leaving it to columns or to beams, let us say beams are also there, load is going on to columns. So this 1 cubic meter of concrete is 2.5 tons per meter cube. So 2.5 tons per meter cube means 1 cubic meter is 2.51 meter cube. So 1/4 of load was 2.5, 2000, so 600 something should go on one column. But your column can take that much already. So it's no problem, you can say, right? You may say, oh, it's very good column. It can take load very light. No problem, it's fine, done. Then why use steel? Why use everything in slab? So that's where I say. That's where point lies in. We have to know that nothing alone can move. One material alone cannot move. It is theory of structure. which is very complicated. Even for those who have qualified engineering, it's also very complicated. Only difference nowadays is that we have excellent software mechanism which help us to calculate, which otherwise would have been calculated using manual or using calculators. Only benefit we are getting in engineering that we have softwares which support engineer. Otherwise also it is difficult now, because once you are used to software systems, then you forget how to do work based on first principles or based on manual calculations. We cannot think of that much, but we rely on softwares. No problem, I don't mind that. Use of software is not illegal. It is good one, it's accurate one, but it stops some mental generation of power. Well, leave that aside now. I was talking about how to understand members of a building or a structure. Maintenance of equilibrium is very, very important point. Maintenance of equilibrium. If you cannot maintain equilibrium, dynamic equilibrium, static equilibrium, and you take out one member or try to repair that member out, or suppose some member you want to extend that one without understanding complete impact on building, then you are going to harm that structure. You will make it handicapped. You will convert your dynamic sound structure to handicap status by just foolishly doing whatever you want to do on that. And I am dead against that, because I cannot change my body, I cannot amend my body, I cannot add some part to my body, I cannot take out any part from my. When I cannot do this with body, how I can do with body of a structure? Because structure is also a body. It's also a body. It's your design body or someone else's design body, but it is properly used, and this body serves you since it was commissioned. So you cannot just blindly do whatever you want to do. It's very important point. I'm trying to educate you on this issue, not to claim something. I'm not the person to claim someone on that. It is you to understand what is right, what is wrong. Structures should be now considered in a different way. It's your life. Your life. It's not everybody's life. Whoever is occupant of that structure, that person enjoys. But that person does not know what it is enjoying. For that occupant, it's a building, it's a structure, it's a room only. And that is measured in terms of commercial value, not philosophical value, or not professional value, or not structural value, but in terms of commercial value, which is ultimate destination of everyone. But remember, commercial value cannot strengthen your structure. Yes, there's a transpass. Money passes from one hand to another hand, and its value is increased for no gains in structure. Just because value changes, value of currency changes, that value increases, but what is actually you're buying for is structure. That point we have to clearly understand. How that structure behaves since it was built in, and during its transition life, after 5 years of its construction, after 10 years of its construction, after 15 years of its construction, after 20 years of construction, how variations come in while it behaves in. When we say bending, again I say this is a very risky material. Bending vertically, bending horizontally, bending out of line, sway of a building, when we stand, what happens? When there's some electric pole, what happens? When winds, thunderstorm, what happens? It collapses. What happens to tree? They are uprooted and down. Why? They're all like structures. Your electric pole is a structure, and in fact tree is also a structure. But because of thunderstorm, it automatically falls. Why this happens? That is a point that we must realize to understand. And that is very, very delicate point. We do not give value to understand it, and we must understand it, and that is where we fail. Structure can also fall if it's not properly founded. It's very built in, you can say, in analysis. In theory, it's very nice. You have considered all forces very well. But you forgot about foundation. You forgot about conduct of soil. That is very risky point. Well, we talk of that, no problem. But now I'm talking of forces. You say, I have put very good walls. I have put in my house very good doors and windows, very good glass, very good plaster and rendering, very good tiles, very good flooring. Yes, all you have. I have very excellent electrical decoration, very good air conditioners. That's okay, fine. That's okay. But remember, all these appliances and inclusions I say, of architectural requirement or even for building requirement, doors and windows and ventilators and flooring, all that relate their lives to structure. All that relate their life to structures, and if structures do not behave according to what designer wanted, or there is accidental collapse, or there is accident deterioration, harmful effects on building or structure, then all these extravagance of our structure you did won't perform in intended way. These won't perform. These will perform in different way. आपने सोचा था स्ट्रक्चर बहुत बढ़िया बना है, हमने हमारे हिसाब से हमने क्या बिल्डिंग बनाई है, क्या वॉल्स बनाई हैं, क्या फ्लोर बनाया है, क्या दरवाजे खिड़की लगाई हैं, क्या शीशा लगाया है, क्या बिजली के लगाई है, सब लगाया आपने। माना किस लिए लगाया? इस बिल्डिंग को ऑपरेशनल बनाने के लिए ये सर्विसेज आपने ली, पर स्ट्रक्चर आपका डेफिशिएंट रहा और उस तरह से काम नहीं कर रहा, तो ये सर्विसेज भी जो आपने ली ऊपर से, ये जो परमानेंट इंक्लूजन आपने लगाई है स्ट्रक्चर के साथ, ये भी काम नहीं करेगी उस हिसाब से जो आपने सोच के लगाया था। Very important point I'm stressing on to you, and my principle says that if structure is deficient, everything is deficient. स्ट्रक्चर में कमी है तो हर चीज कितनी भी महंगी क्यों ना हो काम नहीं आएगी। फाउंडेशन कितनी भी अच्छी क्यों ना बनाई हो, अगर सॉइल उसको नहीं ढंग से ले पा रही तो काम नहीं आएगी। It won't work for you. It won't give you service that you expect foundation to give you. You do not know once your building is done what foundation is working, how it is conducting. You do not know. You know only, oh, some cracks have come in my walls, there has been some sinking of foundation, or there is some settlement of foundation, undue settlement, or more settlement, or unequal settlement. Then you would say, oh, there is some problem. But it's fortunate that building doesn't fall immediately. It never happens. There are so many reasons behind that, worth discussing some other time. But there are so many reasons, so many ways that building still works in, it serves in, despite being ill-treated by foundations or ill-treated by soil or by natural environment. Nature is also very much obliged to help you in your structure. That's true. How much air is entering your home, you do not know. It enters. You cannot expect perfect organization that nothing would enter. My building is airtight. Yes, in theory, we say it is airtight. Weatherproof, you can say. Weatherproof stays. We used to called weatherproof stays in our lifetimes. Let us now consider the building is weatherproof, and we say what's weatherproof stays? Tell me date of your bedroom so that we can start working on how to do it further. Building actually is never weatherproof. Just like we say structure is fireproof, but in fact it's never fireproof. Yes, there is a resistance that we input into that structure so that it can sustain fire for certain minutes or hours. That's what we can say. Similarly, we cannot say any structure or this structure is seismic proof. We cannot say, because you do not know maximum acceleration that apply that generates or that vibrates your structure. We do not know how nature is working beneath. We do not know that. So we can say, okay, up to this level we make it seismic proof, and after that God take care. Because there's limit. We can live in certain limit, just know we do not know our lifespan, but we expect my lifespan may be there so many years or so many years or so many years, but one day we have to leave. Same way is structure. Structure is very complex and complicated mechanism. We know what we have to produce, but do we do that? Are we able to do that? That is what I say. I like to stand for a while. Is it bad or good for you? I think let me just 2-3 minutes I understand because of my, you can say, let me see, I can sitting is too well sometimes. Just keeping this. Okay, let me see. See what happens. So what I am saying is that my leg is very rigid. It's behaving very rigidly. No problem. It's life. So structure speaks to you, and you have to listen to structure. That is very much required. If you don't speak to structure and you don't listen to structure, you do not know what you are doing. And being an engineer, being design engineer, or being implementation engineer, or site performing engineer, or some other professional, you may say contracting, or whoever you are foreman, you are engineer, you are director, or whoever, it doesn't matter as far as structure is concerned. Structure doesn't know who you are, but structure only tries to know what I am. Structure wants to know how I am working. Structure should not pain itself. Structure should behave properly. That is main requirement. And it depends upon how it has been incomposed, how members have been placed in, what forces are overall on a building, and how these forces have been proportionally distributed to various members of that structure. It may be single story structure, or it may be whatever number of story structure. It can be whatever size of structure. Whatever is there should be according to requirement, according to dynamic equilibrium and static equilibrium, and according to theory what is required. And whatever we consider should be for life of structure. And life of structure means durability of structure, which I and you cannot change. And material itself is natural. It's a certain nature. Every material has certain nature, and that nature cannot be changed by you or by me. It has its natural phenomenon, and we all use natural resources for structures. It's not simple that I say something and it can happen. That's not case here. We may think, we may not think, we may do, may not do, but materials speak for themselves. All materials, cement, you can say rocks, water, All are natural material. Us, we have refined them. We use them to suit our requirements. But otherwise, these are natural processes. These are, natural phenomena, and we cannot go against that. So, what I mean is that a citizen who is not from engineering background, what that citizen should do, I am just trying to help it, because some people do not know anything about engineering, about construction, but they accept everything. I can do it. Very dangerous. You do not know anything about something and you claim that you can do it without knowing analysis of that, without considering how it can be done, and you think I can do it. Only for money you say that. Only for money, not for something, not for a structural requirement. And I say structure is not for one day. Your machine can be for few months. Your machine can be for few years. But structure is not for few years. It is forever. It's forever. Because nature produced these materials within its heart for long duration. Just like I say that many times I exemplify, I give examples like materials which happen, I sit down now, you are not comfortable in standing. So when I say these materials, for example limestone, let us say limestone or marble, you think, is it produced in one day? You think so? Limestone or cement or silt, or you can say iron, you think these are produced in one day by God? No, not at all. Nothing can be produced in one day. Means you cannot expect today you have some material, you consume it, and tomorrow you will get more. No, it's not like that. As I give example of petrol, or you can say crude oil, fossil oils. Fossil products we always talk of. What are fossil products? You are using petrol, diesel, gasoline or gas. Generally Americans call gasoline used for petrol. So you are using gasoline. You extract it and burn it. That is your duty, right? You are happy to do that. Oh, we consumed it. Yes, you consumed it. You consumed it within short duration. Just in 85 years, you consumed major portion of reservoirs oil. But you never think that this oil was not produced in 50 years or 80 years or 60 years. It took, I don't know how much, but many thousands years probably to make reservoir of oil. But you have drawn it and fired it. This is what you say. Now because it has polluted all air, it has polluted our lives, and we are now weeping. We are now weeping for low carbons. We are weeping for this and for that. Why? Because we did not understand in the beginning and how harmful it was, or we never cared for that. Either of these. We never cared of that. I have some problem with this water. We never cared for that, and we abused this material. Actually, it is abuse we did. It's abuse. We did abuse on this. We abused this material and we put ourselves in this pollution danger. So if you stay in proportion not accepted by nature, you will face such types of issues. And if you move with nature in every affair you do, you will not face any such problem. That is basics. So that's what I say. structure is not something artificial, it is natural. Yes, it is produced, it is accumulated, you can say. Composite material is produced by ourselves using natural ingredients drawn from nature, and we compose them together and we produce concrete along with use of steel. And these are structures. This could be structural steel as well. Generally I talk of concrete because concrete is very commonly used composite material in whole world, but it is also abused material in this world. People play with this. People play with this material without even understanding this material and without even understanding principles behind calculations or theory. We do not know how some member behaves or how a building behaves or shall behave, and we just take responsibility of that. Oh no, I know it and I would do it. Particularly many people who have never known any kind of engineering, any kind of analysis, who never understand, and they can build anything with overconfidence. They only know how build it and that's it. They do not understand. They have no connection with its parameters, with its conducive stages, how this building would turn into, what distresses or stresses cause shall behave in, how matter shall behave. They have no knowledge, but they can do whatever you say to do. That's not right. Remember, this is material. You can waste it. It's your money. But you got money to waste your money? Or you want to occupy some structure which is risky? Safety is not easy. Safety is not difficult. Both are there. If you are aware, if you know that something is dangerous, how to make it safe, you can do it. Again I say, every structure is risky. Every structure is risky despite design is good. Despite design is good, engineer did everything. Engineering designs worked on all principles, all formulas, all considerations, all trials, and delivered excellent design. But that design is not final product. That is only package of some documents. What to do, how to do. But when it comes to in arms of those who never value designs, who never value so much, but they say we are practical. We are practical. Just doing one or two structures, they become practical. And they did in terms of having no knowledge of that. By chance they see something and they start to do the same thing. What do you call them? When design comes, all details come, these should go into proper hands. Into proper qualified hands who can give shape to your money, to material, and material to design requirement. Those people are available, and those people know what to do, how to do. Those people understand what is structure. Those people understand what is process. those people understand what is material. And if you cannot understand all these and you involve yourself with construction, I think this is nothing abusive, top abusive, nothing only abusive, top abusive, and this is a kind of crime you can do against humanity because you don't know anything about that and you are involved in life risk of others. Just because people can trust you, you are a builder or a contractor and you could do with convenience what they want. But they forget that it's structure. I have noticed that people generally say, oh, see, this building has so many columns. These columns are so size and only so many stories have been constructed on this. I can construct more and more on this. There are people like that. Oh, it can take 2 or 3 more floors or it can take so many. They say without knowing anything because they only know some load is coming. That's it. They do not know more than that. Okay, load is coming. Foundation is there. So they do not care anything and they can add 1 floor, 2 floors with confidence, with power of, oh, I know this. I have done this before. And you, because the tuning is so nice, so polite and with so much impressive commands that you believe that person. You believe that person and you give responsibility to that person for your structure. And here you amputate yourself. That person would construct and run away, go forever. If your structure faces some problem, some issues, there will be no one to help you and structure cannot help you. If there's some fault, some problem in structure, no one can help you. Structure cannot help you because structure is not human being. Structure cannot warn you except giving some cracks or some sinking or some sway or some shift in vertical position. At that time you shall enter in state of panic and which is worrisome because it's a structure. It costs your land, it costs your money and your life goes to risk. And that is very worrisome situation. You cannot sleep because when you sleep you see, oh, this structure in danger. So you lose your sleep, you lose your life, possibly building collapses, possibly something else happens. And that's what I say. It's risky business. Do not ignore structure. Do not ignore it. There was a time when there were no structures, just walls were structures. That was different time. There's no framing in old buildings, in ancient buildings. Yet they are working. It doesn't mean that structure is not required because the walls are so thick which also a kind of constitute a kind of structures. Sometimes we use domes, not lanterns, domes. Yes, it's okay. Dome is a structure, but you cannot place another floor on dome. So that is confined one. That is for some other purpose. But what I am speaking, that is about concrete structure, or you can say framing structures. Framing is very important part. Framing is not easy to understand. It's not your it's not your photo frame. It's not your photo frame. It's different kind of frame. It's very different kind of frame. This frame is not easy. It's 3-dimensional frame. It's 2-dimensional frame. It's multi-story frame. It's high-rise frame. Frame means what actually? What is frame? When I say frame, I should explain to you that also, because that is very important. I say it's not frame. It's not computer frame. They say this is a photo frame it or crop it. No, it's not that. It's not that type of frame. It is material frame. It is frame of your life. It is not one-dimensional frame, two-dimensional frame. It is frame, cross frame, vertical frame, horizontal frame, and many joints in those frames. When we say frame, you understand ordinarily that there are two columns or two pillars and one beam, and there's a foundation, right? There's two columns and two foundations, or joint foundation, whatever it is, and two columns and with beams, and of course slab is connected, so that is called portal frames. Portal frames, P-O-R-T-A-L. Portal frame, that is basics of this. This means this is not an ordinary frame, but this is a monolithic frame. Monolithic. What do you mean by monolith? That is another point to understand. I used to talk to many people, and we used to explain only that this is column, this is beam, this is slab, this foundation, and they think that's what is final. No, it's not final. That is A, B, C, D of English. It's not C-A-T, cat, R-A-T, rat. When we say frame, portal frame, this means just a unit, how we connect these units together. When we say this is foundation, these are columns, these are plinth beams, these are structural top beams, and this is slab, that is considered monolithic first of all. And monolithic means we assume that these are produced one time. Means though practically it's not possible to make them one time, but there is some time gap we consider same time. For example, we can cast footing one time. Footing means foundation. We can cast whole column one time, maybe 4 meters height or 3 meters height. We can cast one time. And if possible, if you say there's a way you can cast whole structure one time, I think that's the best way, but that is not practically possible. So we say in stages, okay, if we say a cycle of 15 days or 21 days, and if in that one we can cast our one story, we consider that there's not much gap in that, and we can say we assume that these should act monolithically. Monolithically means one stone. Monolith. Mono stands for one, and lith, as I said, lithosphere. Lithosphere means solid part of earth. Lithosphere. So here is also monolithic. It is unit stone for that area of structure. It should act in unison. It should not act differently. If I say this quality of concrete I consider in this column, same quality of concrete I consider in foundation, and same quality of concrete I consider in beams and slabs. So one type of material I consider in this monolithic system. This means this is uniform, though practically it is not uniform, but within some tolerance, within some variations, we consider it uniform. Uniform in performance. There are some deviations, but we consider uniform in performance. That is called monolithicism. When we say what is frame, as I said, frame, as I gave you portal frame example, vertical members and horizontal members connected together with foundations, it's framing. Means these act together, these perform together. These cannot perform separately. I am performing as slab, I am performing as beam, oh listen to me, oh listen, I don't transfer my load to you, column, you are not performing well, I hold this load. No, this cannot do like this. This cannot do like this. This just like a machine works. If one part doesn't work, machine cannot work. If my body's one part is disturbed, I cannot be comfortable. Same way as framing. Framing in x-axis or framing in y-axis and framing in z-axis. All these three axes, framing is important. If I miss framing there, I miss everything. So framing, which actually people do not understand, I'm trying to let them know. Structure is framing. In whatever mode of structure it is, somewhere framing is done. And that framing is very complicated but very durable. Because say beam, say column, say slab, load is transferred. Dead load or other load, these are transferred, and there are joints. So joints where your vertical member and beam meet, that's a joint, and slab is also on that. So there are many joints in one structure. If you go x-axis, if you go y-axis, and you go vertically, you will find wherever these members meet, that's called a joint. And joint, because it's many members, it's carrying 3 or 4 members with it, it's not necessary that it will act according to what you think it is. No, it's not necessary. But it will perform depending on what is size of that material. I mean to say beam or column, what size we elect, for what size we consider in beam and in column and in slab, and whatever is there. These bending moments which I told, these bending moments are important. These actually, once reaching joint, these are further distributed to other members. How much it goes to beam, how much it goes to column, how much it goes to other column on distant. It's not necessary that it should go to that column on which is resting, because it is framing. Means it has to be shared by frame. All loads on all joints are required to be shared by framing members. Beams, columns, slabs, or something else, foundations, until we go down and down, and movements always, if you fix them, members, if you fix members, movements are of course reduced, but still they are there. And it's these bending moments which are always very dangerous. These distributions into other joints, this is natural. I can't hold it, you can't hold me, because it is after all natural material in form of concrete or in form of steel, and these actually would work automatically. Even if I want, no force should go onto this, there is no way out. If I put steel in, it will do its job. If I put concrete in, it will do its job. So when these are connected to some other members, some of the joints, naturally, automatically, some part of your forces of bending moment would go to them. Yes, direct loads, there's a less chances for direct load to go to other one, but moments are in different directions at 90-degree angle or whatever angle. These may be shared by other remote joints, in addition to joints on which these members are located. So that's the point which is worrisome, because distribution of moment happens in all 3 dimensions, where we need control. And there is no static analysis of that. Because static equilibrium depends upon triangular state of members. This is vertical forces and these are horizontal forces, and we match them and we say that this is stable. But here forces are not known. We know forces in members, different members, and these keep on changing, because variation of live load do happen, variation of accidental loads do happen, It would happen. Temperature variations happen. So there is natural changes in materials also we used for permanent application. Those do change. We have to realize this fact. If we don't realize this fact, we can't. So these movements which transfer from one joint to other joint cause worry for design engineer and worry for stability. It's not only movements. There are deflections. Deflections means, say I consider some point in slab or beam, when there is a bending, that bending, position of bending itself means beam is down or up. Beam is down or up, slab is down or up from its original position where it was resting. Due to whatever load, it changes, means every second it changes, up and down, up and down, up and down, like this. It goes on. It's not simple. It does like this. I can't do it, Let's see this. Let's see, like this, like this, like this, like this. Beam slab does like this, and column does like this, like this, like this. These keep on mastering vibrations like this, and nobody can change it. You stay on a bridge below which a train passes away, this bridge will vibrate. So your structure vibration is its natural phenomena. When loads are imposed, actions are imposed on structure will behave accordingly, and that's where framing works in. Framing helps to contain that vibratory load, it helps to contain that moment load, it helps to contain sway also. Sway means, what I mean to say is, this is a building, say whole building is this, and there's a wind pressure on this, there's a seismic pressure here around, see what I'm saying. Let's say I'm holding it, though it's not. This is a foundation, this is your top. Now say wind blows, wind, see wind, this is wind, this coming from this direction, coming from this, coming. So this is disturbed, but it's a seismic force is there. You see, is a seismic force. You see what's happening. Seismic force. Your building is shaking in. That's what is required. Your frame in 3 dimension must be able to dampen or digest those swaying in force. This wind force that's swaying in from top, and seismic force that is shaking your building from foundation, these must be contained. If you contain them in structure gradually diminishes them, structure shall remain safe. But if you say, no, I play with one member, I want to raise it, I want to make another floor, then all phenomena is recalculated, redone. That's point we have to be. Say I want to add one floor to something existing one. This means there must have been a provision in last floor you did that continuation is maintained, continuity is maintained, but you did not know that. Continuity of staircase, continuity of columns, and continuity of everything must have been maintained, but you did not do that because that time you did not contemplate what will happen, or you did not even know how continuity could be done, could be made. That point is very, very specific. Generally, people ignore it, and that ignorance is cause of problem. That ignorance is caused of problem and problem and problem. People do not know how structure behaves, and because non-engineering personalities of course play a negative role in that, in you can say titles of contractors or builders, because they are only contractor and builder without having any logical background or calculation or theory background, and because they have seen physically something being done, and they think engineering is physical. That's the only problem. Engineering is not physical, engineering is technical, engineering is theoretical, engineering is calculation, engineering is everything. As I said, bending. Bending is not simply bending, it bends your structure. It bends everything. If this bending doesn't come back, when I say it doesn't recover, bending means deflection. If your deflection is not recoverable, this means you change shape. Do you know what I mean? Let us say it's bending here, but it's coming back. See, it is coming back. If it doesn't come back, that's a problem. Means there is deformation. Right? Whatever was original form, it has changed. Original form has been interrupted. It has been interrupted. This means you have bent it permanently. If I bent your leg, how shall you feel? If your arms are bent, how shall you feel? What happens in fracture? Some defect, permanent defect. I have to. If your nose is bent, what shall you feel? So, structure cannot tell me, but I understand what a structure speaks. It was originally horizontal, perfect horizontal or perfect vertical, but I bent it, or forces bent it. This was not strong enough to contain those forces, to contain for bending moments. People thought vertical force is enough, and they just took column into calculation. Oh, this is quite good in taking this vertical load, and they designed. No, not that. Remember, like I said, light pole, you see light pole. You see your bridge, when train passes, your bridge vibrates. If say train goes away and vibration is dampened, suppose vibration doesn't dampen, this means your bridge is swayed. Same thing happens, as I said, to your building. It is swaying, it is swaying. See, this sway. It is sway. But it comes back. It is sway. It comes back. It is sway. It comes back. It sways. It comes back. It sways. It comes back. It comes back. If it goes like this, it doesn't come back. It goes like this, doesn't come back. So what shall you do? It's come back. Okay, it's come back. But suppose it doesn't come back. It stays here. This means this is design failure, building failure. Right or wrong? Think of. I am not against contractor, and I am not against builders, and I am not against people. I am not against anybody. I am just trying to explain how structure behaves and how you should know. Only problem is, because it's not fault of people. I would not say it's fault of people, because it's not their field. Only fault is these people enter into a field which does not belong to them. They do not represent the field, but they want to make money, and this is wrong way. If you have no knowledge of that field, you should not enter that field, but I can't stop it. Structure performs. It performs from its inception, means from day you pour concrete into shuttering or formwork, structures starts to perform, and it keeps on performing. It doesn't stop. Whatever strength concrete gains and whatever design is given, it continues to perform until that structure is in place. It may be 1 year, it may be 10 years, it may be 20 years, 50 years. It goes on performing, and that performance is not constant as well. It varies because every material changes, Rock particles also change, rock materials also change, steel also change, and there is transmission of moisture into structure all time if it's near water, and also effect of air on structure, effect of sunlight on structure, effect of other chemicals on structure, whatever others you can say, you can count, it works. So we should not understand, we cannot blindly say that, remember, old concrete and new concrete are not related to each other. There is no unification between two. Old is destined concrete, it's already got its destination. You cannot change it. Yes, you can break it, you can demolish it, you can destroy it, that is different. But if you want to keep it useful, then it is already in use, you cannot touch it. Yes, you can expand it by another structure, not same structure. You can expand it. Means you can build another structure with gap of this one. Or you can call it in our terms expansion joint. But completely separate structure. Complete separate structure. Now relation to previous structure. Yes, soil is different. Foundations are different, but structure is not same. So you can expand that area by complete thorough isolation, by expansion joint from top to foundation bottom, and foundation should also be separate. That's what I say. In that situation, combined footings are used. It could be rectangular footing, combined footing, or trapezoidal combined footing. Whatever is suitable, it should be used. Concrete. Suppose you have a baby of 20 years and I say, I want to change this baby. Shall you accept this? Oh, you are a devil, you want to kill my baby? Yes. Structure is not your baby. You spent your savings on that. This structure is allowing your occupancy. You are sleeping in that structure, but you want to change this structure. Just think on. Everything is not pan masala. Everything is not jalebi aloo kulcha. I'm joking. It is a structure. It is beyond your understanding and knowledge. Either you are an engineer or a professor in engineering, it's okay. But you are neither engineer nor other. And you want to take risk for what? For what after all? Why you want to take risk? This material, which is called a structure, is meant for centuries. And you want to you want to bloodshed it. Why? That is difference. Well, I am a person who believe in sometimes ridicule and giving jokes so that you don't sleep. You have certain environment that you should feel calm, you should feel pleased to listen, and it's actually, I also want to sleep, but if I don't speak like this, I shall also feel sleepy, drowsy, which I don't want, because after all, I am also human being. I am not like you, but only difference is that I am thinking in one way and trying to explain what I am thinking. I am not master of engineering. I am not everyone. I have some knowledge of engineering which I want to share with you. I don't believe in only academics. I believe in practical life. Academics is support to that, and practical life is lead to that. If you know, as some people say, before doing structures or before constructing structures or designing structures, we have to understand what structure is all about. What structure is all about. That is very important point which books won't give you. Because engineering is not done in 5 years itself. Yes, you may say engineering education is done in so many years. That is education only. But engineering not that, It's education, it's academics, but not engineering. To know engineering, you have to be in engineering world. You have to be in engineering world of design and in world of engineering implementation. Or you call it execution or prosecution, because everywhere, every point is important, at every stage, everything is important. You cannot frictionalize, you cannot say, oh, this is one part, this is other part. No, it's not that. When I usually talk quality system, this is also part of quality. How to sequence your design, how to sequence your work. It's not simply quality of concrete, it's quality of procedure. Quality of procedure. And this is procedure I am talking to you. When I bring into your consideration bending moment. Bending moment is very important part, because everything can be bent. You may not see, you may not know that the bending moment is working, but it works. It works. Just like you cannot see electrical current is moving into your wires, but appliances prove that it is moving. Same thing, continuity of structure proves that it is working. If it doesn't work, it will collapse. It will fail. It will crush. Its continuity, its satisfactory service, evidently claims, evidently announces that it is working. That's the point we have to be clear of. If we are clear of this point, we can say whatever we want to say. We can say, okay, I am fine. It's okay. We understand what is done, and that is where we stand. Well, I am not going to oppose someone. I would simply suggest, don't take it otherwise. It is your structure. It's your building. You are going to stay in that. And I consider, I hope you stay safe from every aspect. Not from structural aspect, from every aspect. You should say, I sleep well, I walk well, I use this structure well, and I believe this structure is good for me, this is safe for me. That is where. Otherwise, if it's not safe for you, say, there's little defect in that which will disturb your sleep as well. Your sleep well, it will disturb your sleep as well, And sleeping, if you can't sleep, what for is that structure then? Right? What for structure is that then? If you can't sleep well in that, then what for that structure is? So that is very important point. You must note that structural engineering is not what you learn in structures engineering, but what you actually understand by structures. I was really impressed when some says that, oh, I have to think of unity of structural members. That's really word. You have to. If you want good structure, just like you say, my body should be good in all parts. Yes, your body should be good in all parts. Indeed, that's right. Your body should be good in every part. Otherwise, you can't sit, you can't speak, you can't walk properly. Your mind shall not work efficiently, because mind is also part of body, very strong part of body. So just like foundation is very strong part of a structure. If foundation sinks, structure sinks. If foundation fails, structure inclines. So you want settlement of structure, or you want inclination of structure, or you want failure of structure, what do you want? Even if your structure is metal-wise good, design-wise good, but if soil fails, if soil does not support your structure efficiently, or there is some failure, whole your unit of building structure yields. It says, sorry gentlemen, you did lot for me, but soil is not cooperating with me, so I am gone. You must have seen buildings where you say, oh, this building inclined. It was exactly vertical, but it is inclined. Why? Because of failure in soil. Failure in soil. Soil is very complicated word. Though it is soil, it has no money value. But it is very complicated. Whatever kind of soil, whatever class of soil you take in, it's not easy to understand it because it is natural. And nature means non-homogeneous, non-uniform. Because natural agencies all time keep working, and stratification of soil is altogether different. And nothing is constant in this world. Everything keeps on changing every time. Just like our body changes every hour, every moment. Since you were born and since you live this world, till you leave this world, your body keeps on changing its total chemistry, total biology. Your brain also earns different capacities from time to time. Your physical power also changes every day. Your eyesight also changes every day. Your conception changes because of all these changes. Your soul keeps on changing its understanding. And that's what I say. Soil is very, very important material. जिंदगी में बिल्डिंग तो बनाएंगे आप, लेकिन उसको समझेंगे नहीं, उसकी मिट्टी को जिस पे ये स्ट्रक्चर बना है या बन रहा है, आप समझ नहीं रहे, ना समझना चाहते हैं। आप चाहते हैं आप सब जानते हैं, आप जानना चाहते नहीं और कोई आपको समझाना चाहता नहीं। बना के चल देंगे, हमको क्या, अपने पैसे से मतलब है। आप कहेंगे मुझको क्या, मैंने तो किराए पे दे देना है या बेच के चल देना है। यही प्रॉब्लम है। कोई बेच के चल देना चाहता है, कोई किराए पे दे के जाना चाहता है, कोई उसको यूज नहीं करना चाहता। जो किराए पे लेगा उसके पास पैसा नहीं इतना कि वो मकान बना ले अपना। कहने का मतलब है कहीं ना कहीं हर एक का स्वार्थ है। एवरीबॉडी हैज सम सेल्फिश एंगल involved in that structure. But structure does not care for all this. Structure cares for itself. Structure cares that my base should be strong, and base on which I am resting, I will transfer my load. That should also be competent, consistent. But that's formation, we call it, yields and structure fails. So those people who have actually infiltrated to this profession to me, are a kind of criminals who play with lives of people without having that knowledge how to do that job. They want money out because structure is expensive, and they get percentage out of that, even 5 to 10 profit. Good money is made. Build and go. Finish. But structure, they do not even build it according to requirement. They do not understand properties of material. They do not understand what is concrete, what is steel, and what are other materials. What is concrete requirement, they do not understand, but they do and go. This is really surprising that, but it's out of my control. I cannot control it. It's only those people, they have to control, who own it. This is what I try to say. I cannot finish my talk in few hours or few days. There is something keep on coming in my mind because I never prepare in advance. I never do any homework, what I am going to speak today or which chapter of books I will refer to. I never prepare that in advance because I don't think it's required. When you think something, when you start something in contemplative form, this automatically gives you more and more information. Because books are limited, you cannot always rely on books. If you are an experienced person, there are so many books in your mind, though these are not in books form, but in information form. When you start thinking and contemplating, points start coming in, and you can read those points while coming from your brain and conclusively decide what to think, what to say. And also your system is perfect, your health, your body is perfect, so connections from nature do also start coming in. That is property of soul, and that's property soul linked to body, and we know controller of our body is our soul. Just like controller of structure is theory and formula. Without theory, we cannot design structures, and without understanding of theory, we cannot contemplate. Contemplation is ours, but it should be according to theory. So this contemplation is also not basics. It is based on theory. If I contemplate something, this means when I say I have to understand this building, how it shall behave, how shall it conduct, it should be done in consonance with what theory demands, what material properties demand, what do I demand, what do I expect structure to do for me. All that is very important, and we have to recognize this fact. If we can't recognize this fact, we can't do justice with ourselves. That's very important part. I have a few minutes left. I will just like to conclude today's what we discussed because already it's going to be 7 something and more than 3 hours. I'm not in position now to sit because my waist is paining now. So no problem, it happens, but later on I'll increase from 3 to 4 hours. And what we did today, though this title is general, and this is designs, and this is construction, as organization and communication, all that is there, which we will take up later on gradually. And already I have taken this in past, but structure is very important first of all, because definition of structure is not limited, it's not confined to 1 line, 2 line. It's something very different. It doesn't mean what you are educated, it can be learned by everybody. Means at least what is the structure, because structure, we say, oh, what is structure of this body is, you say, oh, what is structure of this body? See, people say like this. How we understand structure there? What structure this boy is? What is your good structure here? What beautiful this car is? What structure? This roller store? This see tractor? What structural design is this? This means if there is something specific or extraordinary in some article or in something, it is noticed, right? This means common mind notices attractions. If there are attractions, not aesthetic, I am saying attractions, performable constitution of every item. If this is not ordinary, people note it. If this is ordinary, ordinary means they often see that, they won't comment on that. But there's something very specific. They speak about that. They comment specifically and not normally. That is what is different. That is where we have to stand. And that's why I am here. To mold with you, to hold you, and to do whatever you have to do. No problem. Structure cannot be defined in one line. It has to be understood because structures are limitless. Single story, single span, double span, 3 span, 4 span, we will say, we will discuss. If public understands what are structures, what's value of structures, I think nowhere in world people still understand this. What structures should be understood even in Arab countries where how many houses have been built, I think there's no limit. How many commercial buildings have been built, no limit. How many big, there is no limit. In fact, you can say everything is built, but public still do not understand meaning of structure. And it's nothing new in our country that people do not know anything about structure. Do not know anything. That's the point where I differ. In building you are living, which building you are living, that itself is a structure. But you do not know that. Your shop is a structure. You do not know that. You know your car, you know your cycle, you know your motorcycle, but these are not very expensive. Your building in which your family lives is very expensive. You do not know about that. That's where I'm interested to share my thoughts with you, that what is important must be known. You are very interested in bodybuilding, you are very interested in health building, you are very interested in everything, but you are not interested where you should be interested. That is where difference lies in. It's not because I belong to civil engineering profession. It's not belong to that. Otherwise also, sometimes you see something, you do not note it. And sometimes you see everything every day, you do not note it. But by chance something comes in your way and you take a note, surprisingly, amazingly. That is very important. But we do not do that. Structure is same. You may say, oh, see beautiful building, how beautiful it is. I'm passing by and I see this building is very attractive. Attractive? Because for you, elevation is very important, aesthetic is very important, color of finishes are very important, but you never think of what is behind. Aesthetic doesn't mean good building, not at all. Good finishes doesn't mean good building, not at all. Nobody would agree with that. Fact remains, and fact also remains, you should not be agreed with that building. Building is building. Structure is very important. If you do not know, because generally people hide structure behind finishes. so you cannot know structure. Generally, architects try to conceal a structure because they want to show only aesthetics, finishes. But without structure, they also cannot do anything. That's also a fact. Structure is a structure, it is authority of none and the authority of everyone. It is very complicated word but useful word. I am not here to tell you how it is designed. No. I am just trying to tell you how it works. Designation of design is different. If I take state of designs, then there's no end. You won't have any interest. And you can't understand without understanding what a structure is all about. Even I have seen engineers do designs, they do everything, and there are others who are also engineers but they do not know anything about that. Well, that is life. Means somebody is working somewhere and somebody is working somewhere. It depends on where are you working and how you are working. It doesn't mean you know everything or somebody else knows something or not. It's different. I cannot comment on that. Now I would say that already few seconds are left to close this video of 3 hours. I don't want to enhance this currently, just to keep it hold on 3 hours. It's enough in morning time. And if I have a person, I'll take some other time. So already 3 hours. So and I also today we have done surprisingly very elaborate talk on structural understandings, structures understanding means unit, and you can say integrity, or you can say one unit of all structures in and its conduct, its behavior in three-dimensional mode. And we cannot say this column is a part a structure or this beam is a structure. Means whole unit is a structure. That I try to explain to you. Moments means bending moment and how these moments conduct, or you can say contribute to performance of a structure. And we cannot poke our nose into that. And if we poke our nose into that, we try to hamper performance and we try to destabilize that structure directly or indirectly, which should not be done. That is very, very worrisome. And it's really I can say good one that we will keep talking in future also same way. So I bid you my wishes, best wishes, and thank you very much. I'm not seeing anybody here, but this video you can watch whatever suitable time to you. And I'll try keeping my input further and further on this. And now I shall request to take your leave from current talk and look forward to see you next time for similar extended discussions or more powerful input which you can. Means it's of course I will think of many times what should be discussed, not discussed, and it's really interesting sometime and not interesting otherwise. But I like to take your now leave of this talk so that we can sit other time and discuss. Of course I have other callings, I have to take tea also, breakfast as well. So I'll be thankful. I'm thankful to you, provided well, I don't say provide, I don't want to put any condition on you. It's up to you. It's your interest. Everybody has different interests, so what is your interest, you know better. I can't say on that anything, It's your interest. If you are happy with this, you like it, it's fine. And if you want to suggest something, you can suggest. I'm not saying you commercialize this, there's no meaning commercialize. Yes, if you want other people should know this, you can share this with others if you wish. There's no compulsion at all. That's all part of game. And it's done. I take your leave now. Thank you very much. Goodbye. I close this now. All right, okay.